Please pay attention. Now our program is going to start. Kindly mute your microphones. Once again, I repeat, kindly mute your microphones for avoiding any kind of technical glitches.
मधुवातादितायते मधुक्षरन्ति सिन्धवः माध्वीर्णसन्तोषभिः मधुनक्तमुतोषसो मधुमत्पार्थिवं रजः मधुदोरस्तु नः पिता मधुमानो वनस्पतिर्मधुमा अस्तु सूर्यः माध्वीर्गावो भवन्तु नः शङ्नो मित्रः शङ्वरुणः शङ्नो भवत्वर्यमा शङ्नो इन्द्रो बृहस्पतिः शङ्नो विष्णुरुक्रमः ॐ शान्ति शान्ति शान्ति
And with this Vedic chant, Haldia Institute of Technology welcomes you all to this 2 days international webinar on linguistics, machine learning, and artificial intelligence. Now, our Honorable Chairman, Sir Dr. Lakshman Chandra Seth, will deliver his welcome address. Over to you, sir.
They have arranged webinar on the linguistic and the machine learning and artificial intelligence. The matter is placed before you for your consideration, deliberation, etc. Nowadays, we have entered into the age of digitization and automation. The application of the computer in manifold. Now the artificial intelligence, as for example, a car moves without the driver. So nowadays, digitalization, but digitalization is very important. Particularly, application of computer is very much important. I have a little knowledge about this. As a chairman, I am, while inaugurating this webinar, I am enlightening upon you that this matter should be discussed properly so that our students community can follow it. Nowadays, Man record less than the machine. Machine can even talk, operate itself. Important. So far as the robot, it is a part of the machine. Act as a substitute of the man. Therefore, the knowledge has been becoming very much important. So far, this linguistic and machine learning, artificial intelligence is concerned. Automation, robotic, and this uh, all are these artificial intelligence. Our students community should be well prepared to know all the things they can discover in this field also. They can also discover device in this field. We are all learned persons, so you will provide your good knowledge and idea how the computer can be better used for all these purposes. I'm very much happy that you are participating in this webinar and you will give your good idea so that our institute can be improved and our students community can be also improved. I have a little knowledge about this, so I will not prolong much. I hope that you will do that, do needful properly. Nowadays, we have entered into the age of automation and machine learning, intelligence, artificial intelligence. So we have to properly use it, utilize it for the betterment of the mankind, betterment of the society. But at the same time, we must be cautious about its use. If it utilized for a better way, it may destroy so many things. It may invite a destruction. However, I will not prolong my speech. I hope that you will participate in this webinar, enlighten so many things in all these subjects. With these words, I conclude my speech.
Thank you so much, sir. Thank you so much for your insightful uh, talk, uh, and that you have been able to share uh, your thoughts with us. Uh, so we heartily thank you, our honorable chairman, and you're also the chief patron. And I know that you are a very, very busy person, but that you could manage some time for all of us and could share your thoughts for that. We, from the whole, from the side of whole organizing committee of this webinar, thank you heartily. Now, I request our honorable director, sir, Professor Manavendra Bandopadhyay, to deliver his speech. Over to you, sir. Hello. Hello.
Hello.
Hello, could you
Hello,
hear
could you
me?
hear me?
I think
I think
some technical problem
technical
is going
problem is
on.
going on.
Hello, creator
Hello, creator
stage.
stage.
Please
Please
confirm
confirm
whether
whether
am I
I'm
audible or not.
audible.
Hello, creator stage. Am I audible?
Hello, creator
Uh,
stage. I'm audible.
okay, okay. Now I request
Now I request
once again
once again
our honorable
our
director,
honorable
Professor
director,
Manobendra
Professor
Bandyopadhyay,
Haldia,
to kindly
to kindly
deliver his
deliver his
speech.
speech.
Over to you, sir, for your welcome address. I think some technical problem is going on. I apologize for it.
Today, in your particular seminar, it has been mentioned that linguistics, then artificial intelligence, then machine learning. These are something different, that is linguistics, something speech is coming out of it, whereas artificial intelligence, machine learning, and rather more development is the deep learning, is the future development with the help of electronics. How they are really days we do not know, but today development of technology has been sometimes is told that future is how we really teach we get to know that for instance uh, with the is another is the
All right, moving to the next. Thank you so much, sir, for your motivating talk and optimistic outlook. Uh, Now, uh, before we get into the main subject area, I feel it should be clear to all of us what the theme of this webinar is and why this particular topic has been chosen. Uh, because here we are having in this 2 days international webinar on linguistics, machine learning, and artificial intelligence, speakers from various universities speaking on various aspects of artificial intelligence and its application. Thus, this brief, in fact, a very brief introduction to the theme of today's international webinar on linguistics, machine learning, and artificial intelligence. Actually, machine came into being, as we all know, in order to reduce human labor, and artificial intelligence is just an extended measure of it. Speaking more specifically, formally born out of Turing's one single question: can machine think? In the year of 1955, um, he proposed his project, and but if we know, if we go back to the history, we'll be knowing that he first conceived this particular idea in the year of 1950, and he put it in his paper, Computing Machinery and Intelligence. And if we turn, if we go a little back, the finding that it was Aristotle who talked about it. However, I'm not going to get into any kind of history or historical talk today. The topic will be elucidated by our other research scholars. But my point is that what I'm trying to say is that this whenever we talk about artificial intelligence, automatically machine, namely the computer, intervenes because artificial intelligence uses machine learning to simulate, to mimic human intelligence. But the computer cannot operate on its own. It has to learn how to respond to certain actions using algorithms and historical data to create what is called propensity model, which then start making predictions like scoring leads, etc., etc., etc. Thus, to feed the computer so that it understands our commands and operate automatically in those areas that demand human intelligence, we need the processing of the natural human language and its programming. And this is here where linguistics come to play a very vital role indeed, because linguistics is but the scientific study of language. Now, linguistics definitely has got several branches, such as historical linguistics, comparative linguistics, psycholinguistics, social linguistics, applied linguistics. Okay, by applied linguistics, again, we are including so many things in it, but here by applied linguistics, I mainly specify the language teaching field. But the branch of linguistics which mainly relates to this field of research with which we are concerned today, that is machine learning and artificial intelligence, is the computational linguistics, devoted to understanding the algorithms that people use to get computers, understand, and produce audio and written material in human languages such as parsing algorithms, dialogue systems, and so on. And with its deeper probe into the human mind to develop from narrow to superficial to super artificial intelligence. The research in this field has also entered into the area of cognitive science, that is the science of human cognition, and thus into more intricate areas of language, that is the figurative language and sentiment analysis. In this webinar, thus,
How these three, such as linguistics, machine learning, and artificial intelligence, act interdependently is going to be our prime focus and is to be elucidated by our invited erudite speakers along with the tasks, applications, and methods in this pandemic time when people are bound to depend on emo, the digitalization, artificial intelligence, basic knowledge regarding these subjects become indispensable not only for technological development but even for our day-to-day work, for minimum mobilization. Hence, today's topic, linguistics, machine learning, and artificial intelligence. Now, I request Professor Gautam Bose, the head of the Department of Mechanical Engineering, Haldia Institute of Technology, to kindly give his keynote address. Over to you, sir.
Okay, good afternoon. Am I audible? Hello? Am
Absolutely,
I
absolutely. You're
audible?
audible.
Yes, sir, you're
Okay.
audible, absolutely audible, audible, audible.
Good afternoon, everybody. It's an honor to be a keynote speaker for this two-day webinar on linguistic, artificial intelligence, and machine learning. First of all, I must thank our respected chairman, sir, Dr. Lakhon Chandra Seth, our honorable director, Professor Bandopadhyay, and all eminent speakers of India and abroad, and our participants. And last but not the least, our program coordinators, Madam Priyanka and Professor Dr. Tarun Kantijana. I hope everybody is staying safe and healthy. Okay, so let me start my presentation. Okay, just a moment. Okay, so linguistic machine learning and artificial intelligence. Okay, so natural learning processing has become one of the integral part of our daily life. Whether we are asking our smartphone for direction or engaging with Alexa or Google, natural processing, language processing, and its subcategories are hard at work behind the scenes, translating our voice or text input and hopefully providing an appropriate voice or text output. Natural language processing makes it possible for humans to talk to machines. It's a branch of artificial intelligence that enables computers to understand, interpret, and manipulate human language. Now, what is this intelligence? This is basically the process or a part of the power to attain goals within the world. Different types and degrees of intelligence occur in people, several animals, and few machines. Intelligence is employed to resolve issues or solve problems. In computer science, an ideal intelligent machine is a flexible, rational agent that perceives its environment and takes action that maximizes its chance of success at some goal. Okay, so artificial intelligence is basically an intelligent machine intelligence. It's the intelligence demonstrated by machines, unlike the natural intelligence displayed by human and animals. The term artificial intelligence is often used to describe machines, which is mainly computers, that mimic cognitive functions that humans associate with the human mind, such as learning and problem solving. So, the various definitions of artificial intelligence, as portrayed by different scholars, are shown. Okay, so the history we know of artificial intelligence way back from 1943. Okay, so it started with artificial neurons and slowly evolved into expert system, industry booms, robotics, and now we are in an era of deep learning with computer visions, Internet of Things. Okay, so there is always improvement going on continuously, right? From the first generation of large data set, data about humans, pattern recognitions, and now we are going into the era of deep learning. Okay, so artificial intelligence started way back, we know, with early system of neuron, and then it evolved into machine learning and finally into the deep learning stage. So the artificial intelligence is any device that perceives its environment, takes action, that maximizes its chance of success. Intelligence is a broader and a number of other flavors of learning take place. So the core intelligence of artificial intelligence is linguistic intelligence, problem solving, perception, reasoning, and learning. So anything that enables computers to mimic human intelligence is artificial intelligence. Machine learning is a subset of artificial intelligence that includes things that enable machine to with experience. Deep learning is always a subset of machine learning. So how based on rule-based system, neurobiology, massively parallel searches, and from perception notification and to situational awareness. This is how we develop algorithm of artificial intelligence. So statistics, machine learning involves a complete artificial intelligence algorithm, and after all, data mining is added to it. So artificial intelligence is basically applied in vision system, robotics, through natural language processing, neural networks, and expert system. So various facets of artificial intelligence incorporates knowledge, processing, wave, technology, multi-agent systems, machine learning, and with the help of reasoning in every aspect. So the types of artificial intelligence incorporates expert system, neural network, genetic algorithm, intelligent agents, virtual reality. So expert system is a computer program that act as an expert in a particular domain. It is a heuristic phases of an expert system, and expert system currently are designed to assist experts, not to replace them. They are basically used nowadays in space research, medical diagnostics, chemical analysis, and other geological explorations. So various domains of artificial intelligence, cognitive science, robotic application, natural interface applications. So in speech and natural language processing, machine learning, we know artificial intelligence are deep rooted. So these companies are using this artificial intelligence in wide spectrum. Now, today I'll just explain some of the applications of artificial intelligence that I have already applied in one of my experimental work, which is multi-response optimization of where EDM process. EDM is electric discharge machining process. Cold steel, die steel using ANN, SA, and GA, artificial neural network, simulated annealing, and genetic algorithm. So basically, a wire ADM machine of MaxiCut E, where the dielectric used is a demineralized water having pH value of 7. External flushings are used, and experiments are organized with a positive polarity of the electrode. Electrode is my copper wire of diameter 0.25. So oil hardened naturally shrinking die steel with dimension 80-80, 16 millimeters are used in small pieces. So the material removal rate is calculated as V into B into H, where V C suffix C is my machining speed, is twice the weight plus the depth. WG is my wear gap, D is my electrode wear diameter, H is the thickness. Surface roughness we are measuring through a profilometer, and overcut we are measuring with the help of a vernier between the distance of the width of cut produced and the diameter of the wire. So the control parameters, we have taken 4 different control parameters with 3 different levels: pulse on time, pulse off time, wear feed, wear tension. And through Taguchi's orthogonal array of 27 experimental runs, we have obtained for 4 variable parameters and the 3 levels. So the respective regression equations of MRR, RA and OC, MRR, material removal rate, surface roughness, and overcut. We have obtained the regression equations for the 3 responses. Then the estimated regression coefficient for MRR is calculated, and it is seen that the sum of square is almost 100%, 99.9%, which is very good, which actually resembles that the regression equation fits well in this MRR derivation. The respective responses are shown with their coefficient, summation of error coefficient, t value, p value, and their interaction, responses interaction, and the interactions among them. So this is the estimated regression coefficient for RA, that means the surface roughness. Here also the sum of square is 97.52%, which is quite good. Next, we have obtained the overcut, regression coefficient for overcut, which is almost 99%. The model summary shows that sum of square is 98.8%, which is quite good. Now, the next step we have done is the artificial neural network, which is basically imitating a biological neural network. It's a neural network nodes which are interconnected in a simple process. Each neuron accepts a set of inputs from other neurons and emit output signals to the output nodes. The action of the synapses is simulated by multiplying each input xi by the associated weight value and transfer the signal to the hidden layer. So this is the net input for each neuron in the hidden layer, and the output of the neuron is commonly described by a sigmoidal function, O equal to 1 by 1 plus e to the power minus I. This is a diagram of ANN where all the different parameters are with associated weights. All the different parameters with associated weight are calculated for the final responses. So the analysis of the results, this is the neural network. We have 4 input parameters. We have 10 in the 10 hidden layers and 1 output. So the data divisions were calculated using the dividend equation, and the training has been done by Levenberg, Marquardt, and performance was mean square error. We have calculated using MATLAB. The gradient and the Jacobian are calculated using the technique called back propagation algorithm. The mean square error between the network output and the target value is applied in the ANN model. Epoch is the presentation of the set of training vectors to the network and the calculation of the new weights and biases. First, the maximum number of 1000 epochs was set to terminate the training for each case. The training performance progress for MRR, the training terminated after 11 iterations where the epoch was 1000. Okay, here the computation, during computation 65% of the data were considered for training, 25% of the data were considered for validation, and 10% data were considered for testing. So the performance plot for MRR shows that the epoch at 7 gives the best validation performance, which is 1.11, where all the training, validation, and testing are converging for mean square error. So regression plot for MRR, the training, validation, and test data and overall data are quite good because the result is converging to almost 1. So training performance for overcut, here we have 6 iterations for converging the process, and 1000 epochs was there. While computing, 70% of the data are taken into account for training, 15% of the data were considered for validation, and 15% of the data were considered for testing. The performance plot for overcut, it gives at epoch 3 with a performance of 3.8 into e to the power minus 5. The regression plot for OC, that means overcut, for training, validation, and test is also very good. We have the result output at 0.99, which is almost 1, and overall is also almost 1. The training performance progress for surface roughness array, the program terminated after 5 iterations at 1000 epoch. Here the computation, 50% of the data were considered for training, 35% of the data were considered for validation, and 15% of the data are considered for testing. So the performance plot for surface roughness, we have at epoch 3 the validation performance of 0.017. Regression plot for surface roughness, we have training, validation, and test data almost at 1, which is almost 0.99 in every case. Now next we have applied simulated annealing. So simulated annealing is basically a probabilistic hill climbing technique based on the annealing of metals. Simulated annealing algorithm adopts an iterative movement according to variable temperature parameters, which imitates the annealing transaction of the metals. Simulated annealing introduces changes in the solution to improve the objective function, but also keeps the solution that, despite underperforming the best one, comply with certain criteria. The solution space is searched by imposing perturbations on the estimates of the parameters that are often optimized. The optimization problem goes like, we have to minimize, because the objective function starts with a minimization of x or z subjected to the criteria. Okay, so here we have a probability of p, which is delta f, which is equal to epsilon to the power minus delta by kt, where k is the Boltzmann's constant and t is the temperature. So the simulated annealing analysis for MRR, maximization of MRR attains its peak while having the parametric combination of T on at 20 microsecond, T off at 25 microsecond, wear feed at 6 meters per minute, and wear tension 12 grams. So next we have the overcut. So overcut attains its peak while the parametric combination is T on at 20 microsecond, T off at 30 microsecond, wear feed at 12 meters per minute, and wear tension 10 gram. The optimum overcut can be seen at 0.3128 millimeter. Now over here we are actually finding out the optimized value of the respective responses, the 3 responses, MRR, overcut, and surface roughness. Through simulated annealing, we are trying to find out the optimum value of the 3 responses from the 4 parameters that we have used. So here in the surface roughness, the roughness attains its peak value through T on at 15 microsecond, T off at 20 microsecond, wear feed at 12 meters per minute, and wear tension 8 grams, where the optimum surface roughness can be obtained at 2.584 micromillimeter. Next, we go for genetic algorithm. Here, we are going for multi-objective optimization. So genetic algorithm is a search technique used in computing to find true or approximate solution to optimize and search problems. Genetic algorithms are categorized as global search heuristics. It is a particular case of evolutionary algorithm. A typical genetic algorithm requires two things to be defined: a genetic representation of the solution domain, a fitness function to evaluate the solution domain. So the plot function of genetic algorithm is shown over here. We have the average distance between individual, generation, we have the score histogram, stopping criteria, Pareto font. Okay. Now the result for MRR, the range is between 8.7598 millimeter per second to 21.3751 millimeters per second. Now the result obtained in genetic algorithm is within certain range. For overcut, we are having 0.3132 millimeter to 0.3860 millimeter. So it's a range. We are not getting any specific result for overcut. So the values into a single value. What will be the maximum MRR, minimum overcut, or minimum surface roughness? For that, we are going for multi-objective modeling using gray relational analysis. This is basically an MCDM, multi-criteria decision-making problem. The weights over here are calculated through fuzzy set theory, considering the triangular fuzzy numbers. Now, through triangular fuzzy number in fuzzy set theory, we have obtained 84.67% for MRR, 3.62% for RA, and 11.7% for OR. This is the weight calculation. Now, combining the weight calculation with the multi-criteria decision making, we have the experimental run for parametric combination, which gives T on to be 18.7 microsecond, T off to be 27.8 microsecond, wear feed 12 meters per minute, wear tension 10.5 grams. That means with this combination, we can have high MRR, low overcut, and minimum RA. Okay. Now, next part, we have a machine learning problem using Python. Now, we are selecting the significant parameters during turning. Now, we have used this Stallion 100S machine, which is a CNC turning center. The cutting tool has a specific specification PDJNL25, 25P15. The tool insert, which is coated tungsten carbide with specification DNMG 150604 TTS of VDMA. We have used a workpiece which is of mild steel. We have considered three parameters, which is cutting speed, feed, and depth of cut, which is symbolized as VDF. Their levels are shown over here. Now, based on the regression policy or regression algorithm, we have calculated the MRR in Python programming. So the R squared and adjusted R square are very good, which actually supports the regression for MRR because the results are 1. Okay. So the overall performance of the variable against MRR is quite good, which is seen from this regression table of MRR. Now the ANOVA we have calculated by programming in Python. So the F value for V, F, and D is shown. Now over here we can find that F value of F, which is my feed, is very high, which is 8 compared to the other two. So this is the most significant parameter in case of MRR. So the residual versus probability plot we have calculated using the program Python. So this is almost a good fit since all the values which is lying almost equally distributing on either side of the line. So it is a good fit in case of the residuals. So the variation of the two parameters against MRR we have shown through the graph. V versus F, velocity versus feed against MRR. This is also calculated and shown through this Python programming. So the distribution of V, how it changes with MRR, and F, CF with F, it is increasing significantly with MRR. This is the variation of velocity and depth of cut with MRR. The variation of depth and velocity are quite small with in case of MRR with respect to feed. Now this is the variation of feed and depth of cut with respect to, okay. So the two experimental work that we have done at our end. Now the last part is the cuckoo search algorithm, which is a new nature-inspired meta-heuristic algorithm, which is very effective for solving global optimization because it is unable to maintain balance between, because it helps to maintain balance between local and global random walks while switching parameters. The cuckoo search algorithm is basically based on the following three rules. Each cuckoo selects a nest randomly and lays one egg in it. The best nest with high quality of eggs will be carried over to the next generation. For a fixed number of nests, a host cuckoo can discover a foreign egg with a probability of 0, 1. In this case, the host cuckoo can either throw the egg away or abandon the nest and build a new one somewhere else. So this is the algorithm for cuckoo search algorithm, cuckoo search with an objective function, and the remaining explains the statement of the algorithm. So the result from this cuckoo search algorithm, the nest is 25, probability is 0.25, step factor L by 100 are examined, total number of iterations carried out 1000. So maximum MRR is obtained at 22068.9.5 millimeter cube per minute for a parametric combination of 184.95 meters per minute, which is my velocity, 0.2025 millimeters per revolution, which is my feed, and 0.7837 millimeter, which is my depth of cut. So basically, this workshop, this 2-day webinar, which incorporates artificial intelligence and machine learning, I have tried to portray the various application of artificial intelligence through the different software programming that is possible and which will be able to fetch the most nearer to the realistic value results which can be applied in various industries. So, and also some of the researchers can carry on or further their research work based on this information for their next stage of research or investigation or in their field of study. Okay, I hope I have covered most of the topics of this webinar. I wish the organizers very success for this hosting this webinar. Thank you all. Thank you once again.
Uh, Thank you so much, sir. Thank you so much for your beautiful keynote address, where you have so nicely covered and presented so many points all together. And now I would like to welcome our next speaker, Professor Dr. Sudeep Kumar Noshkar. Dr. Sudip Kumar Noshkar is a well-known faculty of renowned Jadavpur University who is famous not only amongst the students but also amongst the teachers working in this field. He has innumerable publications, and I hardly need to mention, but if I'm allowed to mention, then I do not think I'd be able to finish the list. But still, to mention a few, and if you allow me to mention the number of papers, it is 122 running. And different other projects he always work on. And to name a few, he has innumerable publications, I'm repeating, and I'll just be highlighting a few so that we can get a glimpse of the kind of work he is working on. Use of machine translation in India, current status, a diagnostic evaluation approach for English to Hindi, machine translation using linguistic checkpoints, and error rates, a lexicosyntactic semantic approach to recognizing textual entanglement, the first cross-script code mixed question answering corpus, the first a phrasal EMBT system for translating English to Bengali, handling of prepositions in English to Bengali machine translation, named entity recognition and transliteration in Bengali, automatic building, and using parallel resources for SMT for comparable corpora, etc., etc., etc. Besides others, he is also the editor of the book Emerging Applications of Natural Language Processing, published by IGL Global, Pennsylvania, USA. He has expertise in natural language processing, machine learning, grammar, language, applied linguistics, corpus linguistics, whatnot, in fact. So let me believe lexicosemantics, machine translation, speech, and information extraction. He has been postdoctoral research scholar in Dublin City University for 5 years, and also the teaching faculty of Vishwabharati University, India. We are really pleased to have you, sir, today amongst us. And without any further delay, I will request you to kindly deliver your speech on natural language processing, what, why, and how, and enlighten us. Over to you, sir.
Hi, Priyanka. Thanks for introducing, and good afternoon, everyone. So I'll be talking about natural language processing. First of all, let me share my screen. Can you see the screen? Just let me know that you can see the screen, right?
Absolutely. Just,
okay.
Yeah, it's fine.
Yeah. Okay, so that was a rather long introduction, a flattering one. Anyways, so I'll be talking about natural language processing, and if you look at the name of the webinar, there are three keywords, topics, linguistics, ML, and AI. If you put these three things together, what you get is essentially natural language processing. So what is natural language processing? It is the ability of computers to process natural language. I mean, computers are dumb machines. They do not understand natural languages. So we will have to develop programs and methodologies so that we can make the computers understand natural language, or at least process natural language text. Now, what makes NLP difficult? If I have to give a one-word answer, the answer is ambiguity. There are so many ambiguities in natural language computers cannot deal with them simply. Computers do. I mean, if I ask you the question of what's not a natural language, the answer will be like programming languages like C, C++, Java. And if I ask you, are there any ambiguities? There are some ambiguities. For example, if you take the asterisk character in C, that denotes both the multiplication operation as well as the indirection operation. But depending on whether it is used as a unary operator or a binary operator, you can easily disambiguate the operation. Or for example, you can also have operation overloading, where a function can have multiple interpretations or multiple functions. So the answer is ambiguity. Because of ambiguity, it makes life difficult for natural language processing. If there were no ambiguities, for example, if you wanted to have a simple machine translation system, it would have sufficed to just build a machine translation system to translate text from one language to another, but that is not the case here. Okay, so I mean, those who are from computer science background, they all know about compilers, and they all know about lexical analysis, syntactic analysis, and semantic analysis. So at every level, similarly, if you want to deal with any languages, you will have to do processing at these three levels: lexical analysis, structural or syntactic analysis, and semantic analysis. And at every level, you will have to face with different types of ambiguities. First, I will give you some examples of the different types, like why it is difficult. Say, for example, if you look at the lexical analysis level, a word can have multiple interpretations. For example, the word dryer can be, it could mean more dry, or the dryer machine that dries clothes. Similarly, I had a look at the participant list. Many of you might not know Bengali. I apologize for that, but I have some Bengali examples. Those who understand Bengali can make sense of these examples. All these words, Bengali words, they have two completely different interpretations. For example, chini, it could mean either the sugar, or it could mean the verb, like I know, the verb know. Similarly, for the example, chuti, like it could mean the holiday, or like someone is running. Similarly, words can represent different part of speech. Words like ship can be a noun or a verb. For example, the word round is very ambiguous as far as part of speech is concerned. It can be a noun, it can be a verb, it can be an adjective, it can be an adverb, it can be a preposition. Similarly, words can also have multiple meanings. For example, bank can mean the financial bank or the river bank. Similarly, letter could refer to an element of the alphabet, or it could be a missive, written missive. Similarly, for ball dance or physical ball. Now, how do we disambiguate such cases? Uh, we just look at the context. For all NLP applications, what we do, what disambiguation we do, we always look at the context. So, for example, John kicked a ball. Here you can see from the context that, kick is a transitive verb. It needs a physical object. So this ball refers to the physical object here. Similarly, the next sentence, the ball lasted until midnight, so it has to be an event. So the ball dance. But if you consider the third one, when you hold a ball, what do you make of it? You cannot disambiguate the sense of the word ball from this context. You need more context, because hold can also mean organize. So you can also organize a ball dance event. Structure. If you go into syntactic analysis or structural analysis, you will also face many different ambiguities. It occurs when you can associate multiple different syntactic structures to a sequence of words or sentences. For example, if you look at the first sentence, it could mean the act of flying planes could be dangerous, or it could also mean planes that are flying can be dangerous. Similarly, for the second one, it could mean relatives who visit your place, they could be worrying, or it could mean that I don't like to visit relatives' places. If you look at the third and fourth one, they look quite the same, almost the same. The structure of the sentences, but they are quite different. In the first one, time flies like an arrow. Here, flies is the verb, time is the subject, and like is a preposition. But in the second one, you can say, fruit flies is the subject, like is the verb. So although they are quite similar in the first look, they are quite different in their structure. And this is perhaps the most used example as far as PPA attachment is concerned. The boy saw the girl with the telescope. So the question is, who had the telescope? The boy had the telescope. He saw the girl with the help of a telescope, or did the girl have the telescope? So this is called the problem of PPA attachment. Where do you attach a particular PP? PP, they modify as a noun or a verb. A noun phrase or a verb. Similarly, if we go into semantic analysis, semantic deals with meanings of words. So here, the main problem is words are very ambiguous. Most of the words that we use in a daily basis, they are, they have multiple meanings. If you look at these two sentences, in both the sentences, you have the word bank and interest, but they are used in completely different sense. In the first one, financial bank, financial interest. In the second one, river bank, and generally interest. Um, then if we go into multi, by the way, Priyanka, how much time do you have? Priyanka?
So you please continue. No
Okay,
time constraint.
okay,
And there
okay,
is enough time.
okay. So then if you go into multi-word units are like, I mean, like multi-word units should be considered as a token as a whole. They have a single meaning. I mean, when multiple words make up a single token or meaning. For example, if you take the first one, John eats in on Sundays. So eats in is here a phrasal verb. I mean, in both the sentences you have John eats in, but in the first one you have the sense of like eating at home. So eating should be considered as a single token. Similarly, you can also have, I mean, John fell for Mary and John fell for Eli. In both the sentences, you have the phrasal verb fall for, again, which could have different meanings. In the first one, it means, John loves Mary. And in the second one, it means John was deceived by a lie or something like that. Okay. Similarly, idioms are perhaps the most difficult multi-word expressions that you'll have to deal with in NLP. Why? Because typically they are very long sequence of words, and the most difficult part is that the meanings of the idioms cannot be made up from its component words. For example, kick the bucket means to die. It does not have anything to do with an kick or bucket. Similarly, let your hair down means to relax. Anaphora resolution, I mean, anaphora and co-reference resolution is one of the biggest challenges in NLP. Uh, so, I mean, you know that, I mean, pronouns do not have any existence of their own. They always refer to something. So in anaphora, I mean, these pronouns are referred to as anaphors. So, but if you are doing some question answering task or natural language understanding or comprehension task, then you'll have to make sense of who the, I mean, you will have to determine who these pronouns are referring to or what they are referring to. For example, in the first sentence, you can see, I mean, them here refers to some people in the crowd, some of the people in the crowd. But in the second one, the word them refers to some of the fire or some of the bullets. Now, anaphora resolution is required wherever you are doing, we need to do some discourse analysis or discourse processing, particularly in chatbots. If you look at the example, so person one says, my sister has a friend called John, and the chatbot says, really, tell me more about him. Then the person one again says, she thinks he is funny. So here the computer has to understand, or the chatbot has to understand, that she here refers to my sister. And similarly, he here refers to John. I mean, when you write text or when we say something, we do not always take the name of the subject. We replace it by some pronoun. Otherwise, the text becomes very repetitive. But when you are dealing with such text, you'll have to reserve who these pronouns are referring to. Otherwise, you cannot do deep natural language processing. Winograd schema. Well, I mean, before this, I go into Winograd schema. I will firstly talk shortly about Turing test. Perhaps all of you know about Turing test, particularly those who are from the computer science background. But Turing test, the Turing test is basically like this. So you are, say, you are in a chat forum, and you are chatting with someone, but you don't know who you are chatting with. Okay, some random person, and the chat session is over. Actually, you are chatting to a chatbot, a machine, some program. And if after the chat you cannot make distinction between whether we were talking to people, talking with a man, talking with a person, or with a machine, then the system, that particular chatbot system, will be said to have beaten the Turing test. I mean, so the Turing test is basically, you'll have to design a system which is as intelligent as a human, so as to continue conversation, a human-like conversation with anyone. So this is basically the Turing test. Now, this is called to be the grand challenge of not just NLP, but in artificial intelligence. But Winograd schema, they have, I mean, the person who has proposed, or I mean, in general, the NLP community, they have agreed that this anaphora resolution task is so difficult. In fact, this problem alone can be said to be more difficult than the Turing test itself. So the Winograd schema is like this. So you will be given a pair of sentences in which only word differs. And because of that word, I mean, whenever the word differs, there is an anaphora in the sentence. It refers to different concepts. So, for example, if you look at this particular example, the city councilman refused the demonstrators permit because they feared violence or they advocated violence. Now, if it was they feared violence, they here will be referring to the city councilman. And if it is they advocated violence, they will be referring to the demonstrator. So this is, I mean, you'll have to make sense of this. But identifying this is not very easy because it just does not require linguistic knowledge. It also requires common sense knowledge or like real world knowledge. I mean, there is an open challenge on which is run by Nuance, which is, I mean, there is a set of Winograd schemas. I think 150 Winograd schemas. And if you can achieve 90% accuracy on this challenge, then they will give you $25,000. So this is an open challenge. Some more levels of ambiguity. If you look at the first one, he noticed us shaking hands. So, I mean, she was shaking hands with someone or her hands were shaking. That is the question. I like tennis. I mean, this is quite ambiguous. So, I mean, do you see the ambiguity? I mean, it could mean I like, I mean, what do I like about tennis? Do I like to play tennis? Do I like to watch tennis? What's that? Then if you look at the pair of sentences, John is eager to please and John is easy to please. They're quite same to look at. But in the first one, John is the subject, whereas in the second one, it basically means John is the object. It is easy to please John. Similarly, the last one, the chicken is ready to eat. I mean, this is how the native speakers say. This basically means the chicken is ready to be eaten, but it could also mean the chicken is hungry, right? So these kind of ambiguities you'll have to deal with in natural language processing. And ambiguities are pervasive in across languages. I mean, wherever you see, from whichever angle, whichever aspect, whichever task you see, I mean, you will see ambiguity. If you look at this particular sentence, how many meanings you can make up for this particular one? 2, 3? I mean, there could be several different interpretations. For example, it could mean I cooked the duck so that she could eat. It could mean I cooked the duck that belonged to her. Okay. It could mean I gave her a plastic duck or plastered duck, something like that. Okay. It could mean I made her to lower her head. Perhaps you thought of this sense. It could also mean I turned her into a duck by some magic or something. Okay. I mean, it does not make much sense, but whenever some text is given to the machine, which is not so intelligent, all these ambiguities become evident to the machine. And if you go into phonetics, it becomes even more difficult. So let us consider the same example. I made her duck. Now, if you look at the sentences which are given at the left, I mean, and so there is a task in speech which is called automatic. I mean, among the two main tasks in speech, the first one is automatic speech recognition. So given a speech signal, you will have to generate the transcription or the textual format. So you can see, I mean, all these sentences sound very similar to the original one. And particularly if you have the two green ones, they do not have any distinction in pronunciation with the original sentence whatsoever. I mean, both of them sound exactly the same, but the computer has to make sense that the green ones, they do not make much sense. So, I mean, somehow you'll have to do this. And I will briefly talk about language processing, but I don't know how much time we'll get. So language modeling plays a big role in automatic speech processing, automatic speech recognition, and for any other natural language generation task, wherever you will have to generate natural language text, language modeling plays a very big role. So language modeling basically assigns a probability to a sentence or a sequence of words. So the basic task of language modeling is to prefer good sentences over bad ones. Okay. So, I mean, from the language modeling model or tool, the language modeling part of the ASR will basically say that I made her duck. The blue one is the most most valid sentence or whatever. I mean, it is the most fluent sentence. Then there is a phenomenon which is called the crash blossom problems. So it came from this example, this violinist linked to jail crash blossoms. So the thing is, these are all valid newspaper headlines. They must have a valid meaning, but they often have a very funny interpretation. For example, I mean, perhaps you cannot make the funny interpretation of the first one, but if you look at the second one, teacher strikes idle kids. What sense do you make up of this? So here the news is talking about teachers are on a strike, so no classes are being held, so the kids are becoming idle. But it could easily mean the teacher is striking the idle kids. And similarly, here are some more examples. I think some like about 1 year ago, those of you who understand Bengali will understand this example. I saw a news headline in the front page of the most popular daily in Bengali, which read Lok Sabhaye Nirav Modi. Okay, so I mean you can understand that this is talking about so Modi, the Prime Minister of India, was silent that day, that particular day in the Lok Sabha, in the and perhaps he did not take part in any of the discussions or any of the rebuttals. But it could also mean there is a person, Nirav Modi, a rather infamous person. So as if he is in the Lok Sabha, but that is not. I mean, sometimes these newspapers they do write this kind of cryptic or funny news headlines. So we'll have to deal with this. If you are building NLP systems, you'll have to deal with this. So NLP is a difficult problem. I mean, here are some more examples. You can see once you read this sentence, oil prices rose, gas prices rose up, you can make some meaning of it. But the thing is, every word in this sentence belongs to at least two part of speech. Okay, at least two. Can you make any sense of this? It is a valid sentence. Well, if you look at the picture, the meaning will become clear. So, I mean, these are shipping ships that ships, right? I mean, ship can be a verb. So these are the shipping ships. So a shipping ship is the one, that largest one at the bottom. So this one is a shipping ship, which is shipping ships. Okay, so this is a valid sentence. But even for humans, it becomes very difficult to interpret this kind of sentences. This is also a valid sentence. Maybe I will not go into the how, I mean, the interpretations of these sentences. You can search them in the internet. And okay, maybe I will take this one. So I'm talking to someone whose name is Will. So the first person is Will, person one with whom I'm talking to. This is the auxiliary. Sorry, this is the auxiliary verb will. This is second person two. This is the main verb will, to decree someone. I mean to decree. And this is second person three, and this will is person four. So person four's will. This is again a noun. So this is again a valid sentence. And this is, you perhaps might think that this is a giverish sentence, but this is not. This sentence is entirely made up of three senses of buffalo. The buffalo city in the state of New York. Buffalo could also mean the American bull. And buffalo is also a verb which means to intimidate or to bully. So this sentence is made up of these three senses of the word buffalo. And perhaps I can also mention here, I did not, which I should have mentioned. So do you see any ambiguity in the term natural language processing itself? I mean, when I say natural language processing, you always refer to processing of natural language, right? Any other sense does not come to your mind. But it could also mean language processing, which is natural. Say, for example, I say this sentence, uh, uh, machines' artificial language processing capability cannot match humans' natural language processing capability. Okay, in this sentence, natural is a modifier of language processing. So it's not that natural language is a whole and then you add processing to it. So even the name natural language processing itself, it contains ambiguity. So I mean, this is the thing. And the problem with this, that I mean, so we humans are so intelligent that we don't often see the ambiguity. But whenever you give such texts to the machines, all these ambiguities become apparent to it, and it has to deal with it. So it has to come up with the right sense. I mean, the right sense which has been used in the particular context. Why else is NLP difficult? Well, you'll have to deal with a non-standard English, particularly these days with the rise of social media platforms. I mean, and there are so much of user-generated contents and so much of non-standard English. For example, if you see the word is and then a couple of O's, I mean, so the user wanted to put emphasis on the word, just like when you see we put emphasis on some words in the signal, speech signal. So he wanted to put emphasis on the written form. Similarly, you'll have to deal with many spelling corrections. You'll have to deal with words like you, which basically refers to you. Here, two is two is a valid number, but here two does not refer to the number two, numeric two. Here two refers to the like t or two, the preposition to. You might think that segmentation is a trivial task, but which is not. I mean, if you look at the second example here, there is a hyphen between York and new, but I mean, we often hyphenate two words to make a multi-word expression. So, like, whenever you put a hyphen, you can just assume that that two words together make up a multi-word expression, but that is not always the case. Here, there is, I mean, it is talking about a railroad which is being built between the New York and New Haven. So this hyphen here is a hyphen between New York and New Haven, not between New York and New as such. Okay. You have already talked about idioms. Then you'll have to deal with neologism, because these days, netizens, even netizen is a new word. Mm, I mean, the users, I mean, netizens, they are coming up with new words. Not just netizens, even new words are being coined in the vocabulary. So, for example, unfriend, the word unfriend did not exist until Facebook came into being. The word retweet did not exist until Twitter came into being. Even the word tweet, it has, tweet has had a sense. I mean, it still has that sense, but perhaps the other sense of the, the current sense of the tweet that we know, the digital tweets, it has taken over the older meaning. Okay, bromance. Yeah, there is a, TV channel, perhaps you have noticed, called Romedy, an Indian movie channel, English movie channel, which basically refers to romantic comedy. And the problem is that, you do not, your linguistic knowledge or computational knowledge will not be able to solve the problem. Only these two parts. Sometimes you need world knowledge. If you look at these two sentences, Mary and Sue are sisters and Mary and Sue are mothers. So sisters and mothers are quite different relations. In the first one, it basically means that Mary is the sister of Sue and Sue is the sister of Mary. But in the second sentence, it does not mean so. It just means that Mary is the mother and so is Sue. Okay. Similarly, named entities play a very pivotal role in natural language processing, because named entities basically refer to the proper nouns. Because named entities, they perhaps carry the most amount of information in a sentence or in text. Particularly if you look at web search or question answering, particularly web search, you'll have to put emphasis on the proponents or the named entities. For example, A Bug's Life is an animated movie. You'll have to identify that A Bug's Life is an animated. It's a proper noun. And when you talk about machine translation, in machine translation, you do not translate the proper names. You keep them you transliterated them. So you translate them phonetically. Okay. Similarly, Let It Be is a famous song. You will have to identify that this is a song. So it should not be translated. A mutation of the 4 gene. Well, named entities, as far as named entities are concerned, in English, identifying the proper names is not that difficult, because you have the capitalization cue. In English, proper names start with capital letters, but not always really, because if you think of the word iPhone is a proper name. It's a product, name of a product. It does not start with I. Here, a mutation on the 4 gene. Here, 4 is a type of gene. You'll have to identify that this is not the preposition for. So this is a type of gene. So this is a special token. So you should treat it as an entity. Well, so NLP is a very difficult problem, and NLP is in fact called to be said to be an AI hard problem. So until all the problems of AI are solved, NLP cannot be solved. But we have made significant progress in the last, particularly 2 decades, I would say. So in order to solve the problem of NLP, you of course need knowledge about the language, because essentially this is a linguistic, you are trying to solve a linguistic problem. Then you need language about the world. And then you need some way of combining these two sources of knowledge. And how do we typically do this? Typically in the computational view, okay, before going into this, maybe I should say that computational linguistics and NLP are synonymous. There is no difference at all whatsoever between computational linguistics and natural language processing. But perhaps there is a subtle difference, because in computational linguistics, linguistics is the head word, so the thrust is on linguistics. Perhaps I'm not sure. And in natural language processing, is the head word is the processing, so the thrust is on processing. But in the most impactful journal that we have in NLP is named computational linguistics. So I mean, there is no such thing as computational linguistics deals more with linguistics and natural language processing deals more with the computational aspects. It's nothing like that. They are synonymous. Well, so how do you solve NLP problems? Mostly, as far as data-driven approaches are concerned, we build probabilistic approaches or probabilistic views of linguistic data or language data. For example, if you're doing a machine translation system, particularly a data-driven machine translation system like a statistical machine translation system, we will build probabilistic translation models which will give us translation pairs like given the word mason in French, it will say that house is a very likely translation. Given the second one, el avocado general, it will say that I mean the general avocado is very unlikely to be a translation of this. And NLP or computational linguistics does require a lot of linguistic knowledge, but sometimes you can also do away with very little linguistic knowledge because if you have the data, you can build systems without knowing a particular language. This is perhaps not the greatest of idea, but you can still go ahead with building your system in a language that you know. I have built a machine translation, or I have worked on machine translation system with at least 2 dozen languages. I don't, for even some of them, I don't even recognize the characters or the alphabets. So there are some approaches which are purely data driven, for which you do not need any linguistic knowledge as such, but it will be a great advantage to have linguistic knowledge. But still, what I mean to say is you can, without having very little, I mean, without having any linguistic knowledge or very little linguistic knowledge, it is still possible to build NLP systems. And particularly from the data, you can use the textual features as the linguistic features themselves. I mean, you can let the text features, or I mean, how should I say it? I should better say it like this. You should let the linguistic features be extracted from the data itself instead of fixing on the linguistic features. All of you know about models and algorithms. I should not perhaps emphasize on this, but what I should maybe perhaps point out here is that NLP encompasses linguistics to a great extent. It also encompasses cognitive aspects, and it encompasses machine learning and AI, and of course algorithms in a big way. I mean, algorithm is a big part of machine learning and AI. Here are some applications. If I think about information retrieval and information extraction, I mean, these are very broad terms. Information retrieval typically refers to web search, the kind of search that you do in web, like Google search or Bing search. Maybe I should say here that web search engines are typically not considered NLP applications because they do very little kind of NLP processing. Although they deal with text, they do very little NLP. And in information extraction, there could be many different tasks. The first and foremost is text categorization or the text classification, which is again a very broad topic. Depending on the actual task, it could be many different tasks. Say, for example, you could do like author classification, or you could even do gender classification, whether a particular piece of text is written by a male author or a female author. You can also identify the age group of the author, like whether a kid has written it or a young person has written it or an elderly person has written it. Similarly, you could also identify domains. Again, domains can be a very broad terms. You can classify between history and geography, this kind of subjects. You can, if you go into computer science, you can make distinction. I mean, it all depends on how you define your classes, and then you will have to have your data. Once you have well-defined classes and data, then you can do text classification. In fact, sentiment analysis, which is the fourth point here, is a kind of text categorization. Sentiment analysis later. Then text summarization, you know what is summarization is. I mean, given a piece of text or on a particular topic, you'll have to come up with, you'll have to develop a system which can come up with a ready-made summary, a human-like summary. That is text summarization. Math word problems, well, I mean, you know, those elementary arithmetic problems. Ram went to the market with 100 rupees. He spent 10 rupees on water bottle. He bought 2 pens, each costing rupees 20. The shopkeeper giving him rupees 5 discount, and so on. He came back to home, and at the end, you have the question: how much money does Ram have now? So you'll have to solve this question. So you'll have to read the text, you'll have to make sense of the text, and then finally you have to come up with the equation for solving the mathematical problem. Now, math word problem is a, in general, very, word problem is the generic term, and then math word problem is like a more fine-grained term. You can also have scientific word problems like in physics and chemistry, but this requires knowledge in the subject as well as real-world knowledge. Then recommendation systems, you have seen recommendation systems in e-commerce platforms like Amazon or Flipkart, but those recommendation systems are very easy. I mean, here I'm not talking about those kind of recommendation systems. Here I'm talking about, if I say you my most all-time favorite 10 novels, can you tell me a novel which I must like? If I tell you my 10 all-time favorite songs, since I'm talking about NLP and I will really make it, let us pick to only the lyric part of the song. If the lyric of my all favorite 10 song, can you suggest me, or say 100 songs, can you suggest me a song whose lyric I must like? This kind of thing, okay? If I give you my 10 favorite movies, can you tell me a movie whose plot I must like? This kind of thing. Similarly, fact checking. In fact checking, you know, with the rise of the social media and with the rise of the user generated content, there are so much of misinformation and rumors which are doing the rounds. So given a piece of text, you'll have to identify whether it is fake or not. So this task is very, very difficult because some news media can be breaking a news, right? Now you don't have support for that news. Now again, but that is a big clue that if you don't have any support for that particular news, that is very likely to be a rumor or misinformation. But sometimes you have, just like the other day in Kerala, we had a plane crash. So before that, we had no information related that plane crash. So the first news that was broadcasted, the fact checker could have easily identified it as a misinformation or a rumor or fake news, but that is not the case. So fact checking is very difficult, and this is very pertinent these days. Some other applications of NLP, well, machine translation is perhaps one of the most application of NLP. The machine translation, the task is to basically translate text from one language to other, preserving the meaning of the original sentence. And the purpose of machine translation is to bridge the language gap. In machine translation, there are several paradigms. I will not be talking about machine translation much, but there are several. There can be different, actually 4 different paradigms. There is rule-based machine translation. Then there is data-driven machine translation, in which again there are 3 different paradigms: example-based machine translation or analogy-based machine translation. There is statistical machine translation, which was like the state of the art, like till 5 years ago, and now neural machine translation has taken over, like in the last 5 years or so. Question answering, which is also referred to as machine comprehension. So the task here is you give a text, people text, and then you'll be asked questions. So you build a system which can make sense of the text and then come up with the exact answer, the proper answers. So question answering, basically it refers to question answering on text. I mean, whatever I said so far, but it could also refer to question answering on structured data like database, because database, you know, the database is a structured data, and there is a separate language for writing queries on database language, on database, which is called SQL. So if I type a question in SQL, and it doesn't matter how big the database is, I mean, the data extraction is very, very fast. Okay. But if you build a question answering system on text, because it has to go through several pipelines and it has to solve many different core NLP tasks. I mean, question answering on text is much more. I mean, no, I would not say much more difficult, but it typically takes much more time than question answering or database. But again, in question answering or database, the task here is to, given a natural language query, you will have to translate the query into the SQL. And if you can write the query if there is some syntactic problem, then you cannot fire the SQL. But if the query is perfect, then you will very easily get the answer from the database. Similarly, from knowledge base, there is a separate language for querying knowledge base, which is called the SparkQL. So here the task is to convert your natural language query into SparkQL. Then text normalization. Text normalization is essentially a very basic pre-processing task. So the task here is to transform the non-standard text into the standard forms, like the dictionary forms. But I mean, a classic example of text normalization is a spell checker, or rather a spell corrector. But it has these days it has become a like an end application. Some of you might have used Grammarly, right? So they have built an entire company, $1 million company, just based on this, just focusing on this particular problem. Then plagiarism detection. So you know what plagiarism these days, I mean, in academics, plagiarism is a big issue. So you'll have to build a system which can check plagiarism in thesis, or in question or question answer scripts, and so on, or in research papers. The other day I was having a meeting with Authenticate, because we have recently got license from Authenticate, and I was surprised to see how naive their system is. I mean, I could very easily write a paper or something which will trick their system. I mean, they use very naive techniques to detect plagiarism. These days we have very sophisticated NLP mechanisms by which you can detect plagiarisms. Then ontology building. Here the task is to, given a a very big corpus, whether you can come up with in a particular domain, whether you can come up with a ontology. I hope you know, all of you know what an ontology is. So in ontology is like a graph structure where you have links between nodes, and those nodes are like the concepts, and the links they are labeled with some relations or some they are like, you can have different types of relations in the ontologies. So this is another very useful task, not in itself, but ontologies are used big time in many different NLP applications, just like the knowledge bases. Then natural language generation. Well, I mean, the way natural language generation is defined, it is defined as generation of natural language text from non-textual representation of data. Okay, so your input has to be non-textual. If you generate text from non-textual representation of data, that is called natural language generation. A classic example of natural language generation is given weather data, like in the meteor data band, they record they have sensors across the cities, and they record like temperature, humidity, rainfall, wind speed, wind direction, so on, in every hour from those stations, and they put them together in the database. So given this database, whether you can come up with a natural language weather report. So that is the task. So your input is numerical data and your output is textual. Another example maybe could be caption generation from text. So which also involves computer vision. So the processing part, in the processing part, you will have to detect the objects in the image. Then you'll have to detect their relation in the spatial domain. Then the output of the computer vision application is the objects and their asymmetric representation, where you have the objects, names of the objects, and their relation in the spatial domain. Say the boy is under the tree, or the cup is on the table. This kind of relations, a graph-like structure, and from then you'll have to generate text. If you go into speech, there are basically two tasks: speech recognition and speech synthesis. The task of speech recognition is to, given a speech signal, you'll have to transcribe it into text. Speech is just another modality of language, just like text. So given a speech signal, you will have to transcribe the text. That is the basic task of automatic speech recognition. And the other task is, the reverse task is speech synthesis. Given a text, you'll have to generate the speech signal, maybe in a male voice or maybe in a female voice. So I think Dr. Shamal Kumar Mundal, he will be talking about speech synthesis. He has done a lot of work, and he will be giving a lot of ideas about how to do this. There is another task in speech, as far as speech is concerned, which is picker recognition, but that is not, I mean, that does not belong to the purview of natural language processing. That is typically considered a task in pattern recognition. But these days, I mean, a new task have come up, which is called speech diarization. So the task is you not only have to identify what is being said, you will also have to identify who is saying that. So say, for example, you are in a meeting and you have recorded the minutes, I mean, you have recorded the entire conversation. Then you develop a system which will take automatic minutes of the meeting. So person one, he said this, person two, she said this, and so on. So if you can build this kind of a system, then it will be very, very beneficial to have like automatic minutes of all the like speech conversations. And then finally, dialogue systems. Dialogue systems are said to be the grand challenge of NLP. Why? Because if you have to build a proper dialogue system, I mean, this dialogue system basically refers to the Turing test, right? But if you have to build a dialogue system, you'll have to solve each and every problem in NLP. For example, you'll have to solve the problem of parsing, QoS tagging, then co-reference resolution, or anaphora resolution, named entity resolution, and so on. If you want to build a dialogue system which can talk in any language with any speaker, then you'll also have to solve the problem of machine translation and so on. Okay, so I mean, this is the grand task of NLP. You'll have to build dialogue system which can converse with people just like a human can. Now I will come into the core NLP tasks. So to start with, there are some basic text processing tasks. Like given a piece of text, you will have to first convert the text into sentences. You will have to break the text into sentences, because for most of the other NLP tasks, they take sentences as inputs. Okay. Now, once you identify the sentences, you go into tokenizing the sentence into words. That is called the word tokenization. You might think that tokenization is trivial, but I will show you a slide that it is not so trivial. Then text normalization, like you'll have to bring the data to some standard format, some dictionary format. Like if you have a word and you cannot map it to some dictionary word, then you cannot deal with that word. So that is basically text normalization. In lexical analysis, the basic task or lemmatization. In linguistics, lemmas refer to the dictionary head word. Say, for example, you are building a simple rule-based machine translation system, and you have come across this word came, C-A-M-E. Now, if you don't know that the root verb or the lemma is come, then you cannot generate the translation of the word came, even if you have a bilingual dictionary. And so the task of lemmatization is to basically, given the words in a sentence, you have for each word you will have to map it to the dictionary form, lemma, corresponding lemma. In morphological analysis, you will have to break the words into morphemes. For example, in this particular case, here I have a Bengali example. I'm sorry for the others who do not understand Bengali. So here the root verb is ball, and there are several morphemes which keep uh, an aspect of meaning to the final word, to the surface word bolechilam. If I'm not very wrong, I think the first morpheme gives the, I'm not sure. I think it gives the past sense, I think. Then cho is for no. The A is for the, I think, continuous. Cho is for the perfect sense. Il is for the past tense, and then am is for the first person. So it gives the sense that it is a past perfect continuous verb, and the person of, I mean, subject, the person of the subject of this verb is the first person. Similarly, maybe I should also refer to here that the reverse task is morphological generation. So given the, say, for example, you are again dealing with a rule-based machine translation system. So you have done the complete analysis of the source text. Now you know that uh, the translation of the root verb is ball, and you know that the I mean, you have all the tense aspect and morality information. You know that the person of the subject is first person. You'll have to generate the way the translation, which should be the Bolechilam from this. Then if we go into syntactic analysis, the first task in syntactic analysis, which is kind of a shallow task, but it is often the first task in syntactic analysis, which is called the POS tagging, because words can belong to multiple part of speech. So you'll have to determine for every word in a particular sentence, you'll have to determine which particular part of speech every word belongs to. And you'll have to do this for the entire sentence. Now, in part of speech tagging, typically, we do not just limit it to the basic part of speech. In fact, for English, the standard part of speech tag set, it has 52 tags. So for example, for verb, if a particular word is a verb, you'll have to also identify whether it is a past tense or it is in past tense or present tense or gerund, this kind of thing. So for this particular example, you can see that JetBlue NNP is for the proper noun. This is verb past. This is pronoun, possessive pronoun. This is noun, determiner, noun. This is WH determiner. This is verb, again, participle, or this is RB is for adverb and JJ is for adjective. So typically for PS tagging models, we use you can use any sequence tagging models, like for example, HMM or CRF. And these are typically used in supervised learning frameworks. You'll have to have annotated training data in order to build a PO stacker. Then the most significant task in syntactic analysis is to come up with a parse tree, a syntactic parse tree for the given an input sentence. So I have shown here both the original tree format as well as the bracketed format parse tree. Now, if you look at the parse tree, I mean, you can either take a top-down approach or bottom-up approach when building this parse tree. I'll let us show you how parsing can be done if you have annotated text data, annotated parse data. So in the parse tree, the lib nodes corresponds to the words. And if you traverse the lib nodes from left to right, you get back the original sentences. And just above the lib nodes, you have the corresponding POS tags. And above them, we have some intermediate nodes like NP, VP, S bar. S bar is for, I think, clause, and so on. Well, so how we typically develop a parser? Well, if you have this kind of a tree bank, which is a tree bank is a set of parsed trees, which serve as the training data for building a parser. Okay, so let us just assume that our tree bank has only these two annotated parse tree. First of all, you will have to extract the grammar from the tree banks. You might readily have the language of the grammar, or you can extract the grammar from the tree banks itself. So you just see what are the different production rules that have been applied in these tree banks, and you extract them. So these are the set of production rules which can be seen in these two. In this tree bank, in this particular tree bank. Then you count the frequencies of each of these production rules. Say, for example, you can see that NP2 pronoun has been found twice, like NP2 this once and this once twice. And this way you compute the frequency of each of the production rules that you see in the entire tree bank. Now, once you have done this, you then divide it by the number of times you have seen this thing. Like if you want to compute the probability of NP to say this one, NP to GTN, this basically means how many times you have seen NP. So you have seen NP 4 times, because you can simply count up from this NP is 1, NP is 4, NP is 2. So in total, you have seen NP 7 times. And out of them, you have seen this production rule being applied 7 times. Okay, so the probability of this production rule is something around 0.6. So from this, what you get is a probabilistic context-free grammar. So how likely is a particular production rule to be applied in a parse tree? And if you have extracted this PCFG or probabilistic context-free grammar, then you can take either a top-down approach or a bottom-up approach to build the parse tree for a new sentence, given a new sentence. Then another task in NLP, another task in syntactic analysis is dependency parsing. Dependency parsing is somewhat different it is quite different from the syntactic analysis. In dependency parsing, the task is to come up with a tree where each node represents a word in the original sentence, and then you will have to identify the relations between these words, how words are related in a particular sentence. I took this example from Jurafsky and Martin book, which is, the book on speech and language processing by Jurafsky Martin, that serves as the standard textbook. So this is given this sentence, this is the like dependency tree. This is a flattened representation of the tree, but this is essentially a tree. You can see that this cancelled, this does not have any incoming node as such. So this becomes the root node of the tree. And then JetBlue, it becomes a child of this. And similarly, flight and morning, since they have the incoming edge from cancelled, they become the children of cancel and so on. So this is like the gold standard dependency tree for this sentence. This should be the correct dependency tree. And I just tried this sentence on the Stanford dependency parser, and I found this one. Here you can see it has some errors. Like you can see it has connected late, which is which should have been, first of all, should have been the adverb. It has connected late with the cancelled, as if the act of cancellation happened late, but that is not the case. In this case, the flight was late. Okay, so this was, you can see flight was and then late. I took this output for the same sentence, dependency parser of the same dependency parsed output of the same sentence, from another tool, which is from Allen Institute of AI, which is also doing very good in NLP. They're doing brilliant work on NLP. I just took this snapshot to show that the kind of mistakes that they do. Here the flight has been associated with the morning has been associated with the flight, okay, as if the flight was in the morning. Now, if you go back to the original sentence, JetBlue cancelled our flight this morning, it is really ambiguous. It could either mean we had a flight in the morning, which was cancelled, or it could also mean we had a flight and that, JetBlue cancelled that flight. The act of cancellation happened maybe in the morning, okay? So you could have two different representations. Then some other NLP. Okay, now if you go to semantics basically deal with meanings of words. Now there are three core tasks in semantics. The first one is, of course, the word sense identification, because this is the main problem. Words can have multiple meanings. So you'll be, in fact, most of the words that you use on a daily basis are very, very ambiguous. Often they have 10, 20 meanings. So given a sentence, you'll have to identify for each ambiguous word, you'll have to identify the exact sense from the dictionary, which is applicable in this particular context. So that is the task of word sense disambiguation. There are many different methods for doing word sense disambiguation, but again, these are all based on the context. What do the context tell you about the particular usage of a sense in a particular context? Then another core task is semantic similarity, where the task is to compute similarity between a pair of words. Given a pair of words, you'll have to compute the similarity between that word, a pair. So it is particularly useful in web search. Say for example, you were searching with soccer World Cup, but there is nothing called soccer World Cup. You should have referred to it as football World Cup. So because soccer and football, they are synonymous or they are related somewhere. So, Google also searches, Google also returns you documents that does not have any mention of soccer, but it has mentions of football. But in many different other applications, like for example, machine reading comprehension or summarization, you will also have to deal with semantic similarity. Then word sense disambiguation, word sense induction. Word sense induction is a task which is typically not covered in textbooks. So this is typically a research task. Here the task is to identify new word senses. So there could be two scenarios. Either you start with no dictionaries and you'll have to come up, after processing the corpus, big corpus, you'll have to come up with a sense inventory or a dictionary. Or it could also happen that you have a dictionary, but you have a particular word which is not at all listed in the dictionary. So you'll have to come up with the meaning of that word, meaning for that word. Or it could also happen that you have a word and the word is also listed in the dictionary, but you will have to identify that this particular word has been used in a sense which is not listed in the dictionary. Okay, so this is a very difficult task. Say for example, the tab sense. I mean, these days we by tablet we refer to the digital device rather than the medicine. I mean, more often than not. So I mean, say for example, I bought a tablet from the mobile store or something like that. Um, you'll have to identify that maybe that digital device sense is not listed in the dictionary. You will have to, your system has to point out that this mention of tablet in this particular context is not listed in the, I mean, the sense in which it has been used in this particular context is not listed in the dictionary. So this is a very difficult task. There are some other tasks in semantics, like for example, semantic role leveling, in which you will have to identify the predicate, the theme, and the argument, and I mean, sorry, the agent, and so on. It is somewhat related to dependency parsing, but there are distinctions between the dependency relations and the semantic roles in semantic role leveling. Scene set creation from corpus, this is like, this has come up like a very new task in NLP. So given a very large corpus, whether you can come up not just with a dictionary, but you will also have to come up with a scene set. Scene set is basically refers to a set of synonymous words. Those of you who know about WordNet is basically a collection of scene sets and relations between them. So this is a very new task in semantics in NLP. Then I wanted to tell you something about the distribution and models of meaning. This is something, well, I mean, there are two different approaches to semantics. One is that you start with some dictionary or some thesaurus, some sense inventory you start with. The other scenario is where you don't have any dictionary or thesaurus. I mean, as far as it has to be machine readable. Otherwise, there is no use of the dictionary. So you don't have any machine readable dictionary that the computer can readily use. So you will have to readily, I mean, given a very large corpus in a particular language, you will have to automatically discover the senses of the words. And you will also have to be able to compute semantic similarity between pairs of words. Okay, so this is called the distributional models of meaning or distributional semantics. This is also referred to as the vector space models of meaning. So the idea is like this. I mean, oculist and eye doctor, they occur in almost the same environments. So if two words A and B, they occur in the almost same environments or context, then we can say that perhaps they are synonyms. So Firth in 1957, he, very famously said that you shall know a word by the company it keeps. Now, if I go into, I will give you an example of distributional semantics. Now, I'm sure maybe some of you know, but you are very unlikely to know this particular word, tesguino. So now I will give you some examples of tesguino from which you can perhaps infer the meaning of tesguino. Okay. So a bottle of tesguino is on the table. So what do you make up of this? Then tesguino sense. Perhaps this is a drink, perhaps this is not, but it must be some kind of a liquid, right? Then everybody like tesguino, then it may be a liquid, some popular, I mean, it may be a drink, some popular drink, but you are still not sure. Then tesguino makes you drunk, then you make up the meaning that it must be some alcoholic drink, alcoholic beverage, okay? Then we make tesguino out of corn, then you get the sense that it is some kind of a beer's kind of a thing which is made out of corn. Okay, tesguino is actually a drink which is made by the Native Americans and which is considered kind of a sacred drink. So this is the thing. I mean, if you have enough context, if you don't even if you haven't heard a particular word, you can still make up the meaning of the word by looking at the context. So this is the notion of distributional semantics. So the intuition of this algorithm, if two words are similar or they appear in the similar context, then perhaps they are quite similar or synonymous. Now, in distributional semantics, we use a data structure which is called the term context matrix. So in the term context matrix, the row corresponds to the term. I mean, these terms are the unique terms that appear in the vocabulary or in your large corpus. So if you, in your corpus, the vocabulary size is n, which basically refers to the number of unique words in your corpus. So you will end up with a matrix, a square matrix of size n by n, where each row will correspond to a word and each column corresponds to a context word. Now, how do you compute the context? Now, for the entire corpus, the way we look at the context is we consider a fixed size context, say, for example, plus minus 5 words. So we consider for every word, we look at 5 words to its left and 5 words to its right. Say, for example, I see the word data in the context of apricot, so I add a count here. It becomes 2 and so on. So initially, I started with all zeros, and then after taking into consideration the context of all words in the entire corpus, I come up with this term context matrix. Now, if you look up at this, I mean, this thing that has been encircled in a red rectangle, this row gives you the vector representation or the context vector representation of the word apricot. Okay. Similarly, the second one, it gives you the context vector representation of the pineapple. Now, if you look at these two context vectors, they look quite like the same, right? So we can perhaps say that apricot and pineapple, they are quite similar. We're not sure whether they are synonymous. I mean, this is a very small example. I mean, because the vector size will be very large, I'm just looking at a very small snapshot of the term context matrix. Similarly, you can see that the distribution of context words in the context vector of digital and information, they look quite like the same. So they might be quite similar. And while computing this distributional semantic similarity using the vector space model, we do not generally take into consideration the raw counts like these ones and twos. We convert these values into PMI, which is concept borrowed from information theory, which is called the pointwise mutual information, which computes the PMI of a two events, that PMI between two events. So here you can think of the words as events, okay? So the PMI between two events is gives you the notion of whether two events co-occur more than by chance. Okay, so if the value is high, there is a very high likely that they co-occur. Okay. And then finally, we compute the PMI for the entire matrix, and then we consider their vector similarities. And then finally, we consider PPMI, which is called the positive pointwise mutual information, which is nothing but the PMI. It's only that we just discard the negative values and we just turn them into zeros, so that in the vector space, we don't have to deal with negative values. Here are some more NLP tasks.
Hello, sir,
Yes.
can you hear me?
Yeah.
Sir, if you don't mind, you please kindly check the WhatsApp.
Kindly check what?
Your WhatsApp. There is a message from the organizing committee, a request.
Okay.
Just your WhatsApp. They're requesting for a few minutes.
Okay. Sure. I mean, how much time do I have for the presentation? And then I will go to wrap up accordingly.
If you kindly wrap up and go to the question answer session,
so
then they will be having some time for the question answer session. That's one.
Okay. Okay. So I mean, how much time do I have until I wrap up? Like 5 minutes?
So it's over, fine. But now you can wrap up and go to the question answer session.
Okay, maybe I will just talk about these tasks.
Yeah, you please complete this one, and
okay.
then I'm just requesting for the question answer session also.
Yeah, yeah. Okay, so there are some more core NLP tasks like named entity recognition. I have already talked about named entities and their importance. You'll have to identify the named entities. Now in English, perhaps this is somewhat easier, but if you go into like Indian languages, or there are several other languages where you don't have the capitalization clue, and if you consider Indian languages, most of the persons, they are very dictionary names. Okay, so you'll have to deal with this. Then textual entitlement is a task where you are given two pieces of text, take T and H, and say, for example, T is ABC was murdered on this particular date, in this particular place, in this particular time, and so on. Okay, and H, which is referred to as a hypothesis, is ABC is dead. Okay, now if T is true, then H must be true. So it is to decide the truthness of H based on the truthness of T. And textual entailment is like a directional relation. ABC is dead does not necessarily mean ABC was murdered. And paraphrasing, you know what paraphrasing is. But you can think of paraphrasing as a two-way entailment. If A entails B and B entails A, then A and B are paraphrases. So we can solve the problem of paraphrasing by using textual entailment, or you can also use textual similarity and other kinds of methods. Entity disambiguation, well, named entity recognition is one task, but named entity disambiguation is another task, because you can have multiple persons or multiple organizations which are referred to by just last night I checked with Liverpool, and I found that there are 19 cities around the world which are named Liverpool. In the UK alone, there are 3 cities named Liverpool. So whenever you get a mention of Liverpool, you will also have to understand, or you'll have also have to link with which particular Liverpool in the knowledge base it is referring to. So this is called event disambiguation. Well, event identification is when some text must be talking about some events. This is particularly relevant for biomedical texts, where some text is referring to some, particular medical events. So some text triggers something, like there are a lot of symptoms, but there may be one particular symptom which should be taken into like deep consideration. Okay, so that kind of a thing, and maybe I will finish it here. So in NLP, we heard, we hear about NLP. Super, I have talked about natural language processing. I've also talked about natural language generation a bit, but there is also another term which is called the natural language understanding. I mean, NLP encompasses them all, you can say, but you can also say that NLP or deals only with the processing part, because in NLP the input is text, the output may or may not be text, but in NLG typically the input is not text, the output must be text. And NLU is nothing but just deeper understanding of text. Like for example, I said that, get the example of I like tennis, and if you ask me to develop a machine translation system from English to Bengali, and you give this sentence, I like tennis, and my machine translation system translate it to ami tennis, say I love tennis, ami tennis bhalobashi, you'd be happy, right? But this machine translation system preserves the ambiguity that is there in the text. Okay, so it does not tell you whether I love to play tennis or watch tennis. But if if you are dealing with a question answering system, you'll have to disambiguate that. Okay, so it requires just deeper natural language understanding. Natural language understanding is nothing but deeper natural language processing. Okay, maybe I'll stop here, and
Uh,
then I'll
yeah,
take up.
sir. So two questions.
Yeah,
One is regarding the semantics that you had said. We have a question that colorless ideas, green ideas sleep furiously. So they have asked for an explanation of that. If you can kindly explain that.
what's the question? Is it there in the chat box?
Yes, sir. It's there in the chat box.
Uh, I cannot find
Colorless
it.
green, sir,
Yeah,
colorless
yeah,
green ideas sleep furiously. What about that? Means you're talking about the syntactic ambiguity that a
yeah,
man moving with the telescope.
yeah,
Means I saw a man with the telescope. So
yeah,
whether it's with the help of the telescope, I saw him, or is it the person carrying the telescope? That
yeah,
was the main question.
yeah.
Means you're explaining that from that viewpoint. He has asked one of our participants that how
Colorless
to explain
green
ideas
ideas.
sleep furiously.
Sleep.
That famous sentence.
Yeah, yeah.
Means it
So
is
what
also
is the
full of
question?
ambiguity.
Yeah, it is
So
also full
he
of
is also,
ambiguity.
yeah, that is what he is asking. Wherein, means he's asking for the analysis. Wherein lies the ambiguity?
Well,
How?
you'll have to excuse me for my linguistics knowledge. My linguistics knowledge
Sir,
is
you
very
have
limited.
actually already explained. I think maybe the
But yeah,
participant was having a bit of confusion. If we see
so
that
is there the
colorless
question?
green ideas,
Yeah,
means they are colorless and they are also inanimate. So how they can sleep? They're already ideas. So colorless as well as green. We are having this oxymoronic
yeah,
yeah, opposite words placed side by side. So this
yeah,
kind of ambiguity, syntactic as well as semantic ambiguity also you're having. So I think it has already been explained by you.
yeah.
Now,
I would just say that these kind of things are very difficult to parse for a parser. If you have genuine
yeah, yeah,
ambiguity,
absolutely,
if you can associate multiple different structures, valid structures with a particular sentence, then
absolutely.
without having discourse level context, if you don't look at further context, it will be difficult to parse
Exactly.
such sentences.
Exactly. Context is very, very important. And one more thing, you said that you might not require the knowledge of linguistics. Professor Mahidas Bhattacharya has put a question. Do you feel in course of time, linguistic knowledge may not be necessary as human does not need such knowledge after certain age?
I'm not sure whether the human does not need such knowledge, because I'm just picking up the Spanish language and I also want to pick up another language, sign language. In fact, I was talking with Moida sir regarding this, but
Okay, okay.
I don't think at any point of time linguistic knowledge would be relevant as far as computational linguistics or NLP is concerned. I know these days neural systems are coming up which do not take into consideration much linguistic knowledge, but there has been a lot of criticism of the neural models, that they are completely opaque.
But sir, when you were talking about this POS tagging, it's my
Yeah,
just
yeah.
clarification. When you were talking about this POS tagging,
Mm.
how you would be doing it, or morphological analyzer, or this chunking part,
Yeah,
they need the basic grammatical knowledge.
yeah. I mean,
So in that case,
if you keep it to only part of speech tracker, part of speech tagging is typically solved using a supervised approach for which you need training data. So we'll need to have a lot of sentences for each of which every word is POS tag assigned. Now that data has to be generated by professional linguists. I mean, you cannot. I mean, it is not an unsupervised task. You'll have to have linguistic data on which you can train your systems.
thank you, sir. I think all the questions we have answered, means two questions we had, it has already been answered, and I think uh, Bhattacharya sir would also be very satisfied. And now I think it is clear to everybody that why I gave such a flattering introduction to you.
Priyanka,
You deserve it.
maybe I'll just end it with one comment. So
Yes,
these
sir.
days, a new trend of research has come up which deals with interpretability of deep learning systems. Because deep learning
Oh,
systems are completely opaque, it gives you only weights, okay? And you cannot make any sense of those weights. They work, but we don't know how do they work, okay? So
absolutely.
there has been a completely new trend of research on interpretability of deep learning systems or neural network systems. Okay, I'll end with that.
Okay, thank you. Thank you so much, sir, for your insightful talk and sharing your research experience in this way so elaborately. And thanks to you also for covering such a wide area, because here we have several research fellows and students, and I'm sure all would be very much benefited today from your talk. Thank you so much. And now I welcome Professor Shoman Pal, the head of the Informational Technology Department of our college, Haldia Institute of Technology. He has nearly 14 years of teaching experience and 10 years of industrial experience, and has deepened, which has actually deepened his knowledge in this field of study. He has authored several high quality research papers, all having Google Scholar citations. It hardly needs mention, in fact. And some of them I include here. I just read it out. Building a database for brain 18kDA translocator protein image using 11C PBR28 in healthy subjects. Brain and whole body imaging of all-linked N-acetyl glucosamine hydrolase enzyme in healthy humans, monkeys, and mice using PET ligand 18F OGA1, changes of binding and of cerebral adenosine A1 receptor antagonist 11C MPTX in rodent encephalitis, adenosine A1 receptors in the central nervous system, their functions in health and disease, and possible elucidation by PET imaging, use of 11-CMPDX and PATE to study adenosine A1 receptor occupancy by non-radioactive agonists and antagonists, the effect of endogenous endosine on neural activity in rats, and FDG PET study, etc., etc., etc. So many are there. I'm not getting into that because yeah, let us get into another insightful talk instead of spending time here, which we can get it from the Google Scholar citation also. Now I request Professor Shoman Pal to kindly throw some light on his today's topic, neural network and genetic algorithm. Over to you, sir.
Good evening, audience. Uh, it's my great privilege of presenting this topic in front of all of you. Thanks to our chairman, sir, of the Institute of Technology. Thanks to our director, all the participants, conveners, and organizers. Now I have to start my presentations right now. ওখানে একটা ক্লিক করতে হবে। ওখানে একটা ক্লোজ করি। হ্যাঁ। এখানে এখানে একটা ক্লিক করলে উপরে এই জায়গাটা আপনার এটা শো করছে না স্যার। আমি আমাকে না একটু আচ্ছা ওখানে ক্লিক করলে হবে না, এটা তো আমার এটাই দেখাচ্ছে না, এটা শো করছে না আমাকে। কেন পাওয়ার পয়েন্টটা শো হচ্ছে না কেন? আমার তো হচ্ছে এই যে পিপিটি এটা শো করছে না। না এটা কোথায় গেল? এটা কি ওপেন রাখতে হবে? ওকে করুন। ঠিক আছে না, ওটা তো করে দাও। হ্যাঁ হুম ফুল স্ক্রিন কর। কি পিপিটি দেবে তো? এই যে ঠিক আছে আচ্ছা এটা কত করে ক্যামেরা? আমি বল এটা ফুল
Sir, sir, please, sir, please start the slideshow. Slideshow
yes
from the beginning. Sir, sir, go to this slideshow as I'm showing it up.
এই তলায় আচ্ছা ঠিকই আছে।
slides to
আচ্ছা এটাই স্লাইড
Sir, as I'm showing you, please follow the cursor, sir, on the screen.
আচ্ছা এইটার জন্য হচ্ছে
Sir, please click here.
এটা স্লাইড শো থেকে হবে তো।
Yes, sir. Please click on it. Otherwise, sir, you can also start the presentation in this way. You can see. I believe there is some technical glitch. In fact, we are facing this from the very beginning only. Hello, Shuman sir, can you hear me? Hello, sir, can you hear me?
Yes,
Sir, you kindly go to that slideshow option in the taskbar, just at the top. You show the screen as you are showing. I'll be showing you.
ওইটা অন হয়নি, অন করো, পিপিটিটা অন করাই ছিল, বেরিয়ে গেছে আবার।
এটা অন করার দরকার হয় না, একবার ডাইরেক্ট শেয়ার ফোল্ডারে চলে যাবে।
হাইড করুন, হাইড করুন।
So you kindly switch on the PPT.
Yes, yes, I have switched on the PPT. PPT is now open. Let's full
But we
screen.
can't see, sir.
ফুল স্ক্রিনটা করো, যান ক্রমে ঢুকুন, স্টপ করুন, আগে থেকে স্টপ। হ্যাঁ, এবারে প্রেজেন্ট করুন। হ্যাঁ, ক্লিক করুন, উইন্ডো। হ্যাঁ, শেয়ার করুন, দেখতে পাবে তোমরা।
Yeah. Sir, now please follow. Sir, please follow. Please look at this slideshow. Can you see the cursor in the meeting, in the Google Meet? Please see the cursor. Slideshow. Show. I'm showing you.
এই তো, চলো।
Is it okay?
Yes, sir. Yes, sir. Fine. Absolutely. You may start, sir. You may start. Hello. Sir, is it fine? Shuman, sir, can you hear me? Hello. I'm extremely sorry he is having serious technical issues. In fact, several speakers from the beginning are having. Extremely sorry, but he is facing serious technical glitch. There has been no internet, and now I think he will be able to present shortly. Please bear with the situation. I'm really very sorry. And these things can be avoided also. Means it's not in our hand. This is also one of the demerits of this meetings in Google platform or this online meetings. And this will have to admit, though we are working out several benefits, but some such problems, like if there is no connectivity, we'll have to bear the situation.
Sir, you may start the presentation. Unmute yourself. Unmute, sir, unmute yourself. Unmute yourself. Sir, kindly unmute yourself. Can you see the mic sign? Please look at the meeting. I'm showing you something. Please unmute yourself. Yes, yes, fine. Now please start. Please start. Go to the slideshow. Sir, please follow. Go to the
Is
slideshow.
it okay? Is it
Yes, now
okay?
it's fine. Yes, now, sir, it's fine. Now everybody can see. Please start.
Now may I start?
Yes, please start, sir. Please start.
Okay. So, good evening, audience. I am Shoman Paul, and it's my big privilege to present this topic in front of you. Thanks to my chairman, sir, director, sir of Haldia Institute of Technology, all the participants, conveners, and organizers. Now, my topics to discuss here about the application of genetic algorithm in linear higher order control systems using signal correction technique. Now, before that signal correction technique that I am using it for the deadbeat response of the control systems. This is the linear continuous control systems where I have used the signal correction technique with the application of genetic algorithms by signal correction technique. So first of all, that I have to say that anyone from electrical and electronics engineering, they may easily understand that what I actually do present and how to use the genetic algorithms for getting the deadbeat response. Now, these are the characteristics of the deadbeat response. That the first characteristic is a zero steady state error. That means there is no steady state error, or that means that whenever that system is being stable, there will be no oscillations and no error at the output. And minimum rise time should be the minimum. So rise time will be as less as possible. And minimum settling time, that means the time response to be settled in the minimum duration of time. And overshoot and undershoot will be very small. That will be not more than 2% of the overshoot. And that is our, I mean, that should be the desirable. And another thing was a very high control signal. Now, what is the background of this particular work using genetic algorithm? That concept of deadbeat is not very is very old. but it is very old and lot of interest already been shown in the field of research and engineering field, and in both the cases linear as well as discrete control systems. Now, what is the use that I have to first say that the deadbeat response to be used in the flight control systems in industrial plants, UPS inverter, rocket missiles, and balancing robots, and many other biological systems also. So now what I have to say that what is called the signal correction technique. That signal correction technique, a technique actually that are in the deadbeat, this is the control systems, and here this is a plant, and there is a feedback loop, and that is the reference input. That input where it is mentioned, this is the reference input, that is the original input that has been passed through a plant, and there is a feedback path also, and this particular systems whenever it is now working, then we have to put one additional signal. That signal may be in terms of pulse or maybe in terms of state space, whatever be the signal, and that signal has to be generated through this feedback loop, and that has to be added again to the reference input. So the signal correction technique means that we have to inject an additional signal to the reference input of the original system. And system may be the any order, maybe the second order, maybe the third order, maybe the fourth order, or it may be any higher order systems. So this is the signal correction techniques, where from this plan that the signal has to be generated through this system, and then again it has to be injected to the original system as an additional input. So there are two inputs in the system. One is the reference input, and another is the additional signal which to be generated through the system and to be injected into the original systems and to get the deadbeat response. Now, a technique of injecting and suitable additional signal to the system along with the reference input to get the deadbeat response. That is the SCT, that terms for the signal correction technique. This technique to be used for the removal of the system instability and modifications of the system nonlinearity. And this type of signal correction technique also can be used in the nonlinear system, where nonlinear systems asymptotically to be converted into the linear system, and whatever the signal correction technique, whatever the additional signal to be used in the linear system, asymptotic linear system, the same signal to be used for the nonlinear systems. So that also to be used for the nonlinear systems, because nonlinearity systems, for example, is the inverted pendulum. This is the nonlinear systems, where inverted pendulum, that systems to be normalized into a asymptotically to a linear system, and we have to use some additional signal. It may be in terms of pulse, maybe in terms of the signal. So whatever be, that has to be used to make it into a deadbeat system. So this is the picture of the transient systems in the time domain response, and that is that input, one certain input has been given, and this is that oscillations, this is the output of the original systems. And after adding the additional signal, after using the signal correction technique, that becomes a deadbeat. And you see, this is the deadbeat. That means it is a stable in the rising time. So here, this is the input. That means that whatever the input may be the one, maybe the step input, maybe the ramp input, maybe some other input, maybe the sinusoidal input, whatever be the input. So that it can be made as a deadbeat system using some additional signal to the reference input. And here you see that here I have used the step input, unit step input, and here you see that oscillations part where it will be the stable after the long duration of time, but here it become stable at this moment. So some additional signal has been used to make it in a deadbeat, and that system is a quite stable. Now I will go through the genetic algorithm, how genetic algorithm to be used to make the deadbeat response of a linear control system. Now see, here this is the nature of the additional input, additional signal which is generated through the feedback systems of the original systems. There are the three parameters. One is T1, another is T2, another is B. T1 is the starting time of the signal, T2 is the end time of the signal, and B, that is the amplitude, that means this, that is the amplitude, that is B. So this is a, this is a pulse signal. So we can generate a pulse signal through the feedback system to make it a system to be a deadbeat. So now what I will do it, first select the start time T1. T1 is the time where that time, that in this particular time that the signal, that the additional signal has been started, additional signal has been generated. And what is the T1? T1 as the rise time of the uncompensated system. Uncompensated means it's the original systems. That original system that I had shown you in terms of oscillatory shape. And compensated means that is the after deadbeat response. Uncompensated means it's the original system and it is selected same as the instant when the uncompensated system response attains 90% of its final value. So here you see the figure, that figure I have already shown you. This is the figure. This is the figure. This is the uncompensated system. That's the blue. That's the blue line. This is the uncompensated system. This is the original system. And this is the rise time where there is a break that you can see it. There is a break, and this is the time T1. Now, how can I get the T1? That is the starting time, and that T1 is got the T1 as a rise time of the 90% of its final value. Final value means that whenever we are giving the input of the step input, that means step input of unit 1. So 90% means at the point 9, whenever it will attain the point 9 of this graph paper, that T1, that the pulse signal has to be generated with the starting time T1. So T1 is a time that we have assumed that we are not taking that exact rise time, that 100% of its final value. We are giving the 90%, we are taking the 90% of its final value. That someone can say that we can take 80%, someone can say we can take 95. But to make the stability of the systems, we have assumed that 90% is the value where we have to start the additional signal to the reference input for the deadbeat response. Now end time T2. What is the end time? This is the T2. This time is T2. That particular time is T2. And what is T2? T2 is equal to T1 plus TP by 10, where TP is the time of the first overshoot of the uncompensated system. So that is the time for the first overshoot. There are two types of shooting. One is the overshoot, another is the undershoot. So TP is the time of the first overshoot of the uncompensated system. So here we have used that value had been actually that the value of the T2 that we have obtained through the heuristic approach, that how that value has to be set. But this is not the final one. That final tuning we have to go through the genetic algorithm. So, and to find the pulse amplitude B by minimize the second overshoot given by 4. 4 is the equation number of the uncompensated system. This is the equation 4. And what is this? The expression of the second overshoot of the compensated system is that is equal to this. What is O? This is the time of the second overshoot of the uncompensated system, and C of TP2, that is the, actually this is the time. CTP2, that OTP2, that is the actually the, this one is equal to this minus A. What is A? A is the value of the step input. And what is C of TP2? This is the time of the second overshoot. So we have to minimize this one. So whenever we have to minimize this one, then we will not get, we cannot, our objective is not to get any overshoot and undershoot. So that type of overshoot we have to minimize. So the question is that why we are not going to minimize the first overshoot time? Because that whenever we have to minimize the first overshooting time, then that time that the rise time may be the high. But the characteristic of the deadbeat response is to minimize the rising time of the systems. This is one of the characteristics of the deadbeat system. Now, this is the time domain response in that I have already clarified, that in the second order systems at time TP2, after adding the pulse signal after time T2, where is T2 is that definitely it will be that T2 is less than T, less than infinite. Okay. Now we have got the two equations, because now what we have to do, we have to first, we are not using the genetic algorithm. First, we will use that gradient method, and we have to minimize these two equations. That means that is an optimization problem, that we are having the three parameters T1, T2, and B. T1 is the starting time, T2 is the ending time, and B is the amplitude. But T1 is already, we have assumed that the 90% of the rising time. So we have to minimize that particular equations with respect to n time T2 and the amplitude B. So here, this is that first order derivative, that is equal to 0 with respect to the amplitude, that we are making the partial derivatives. And here also we are making the partial derivatives with respect to T2, that is the n time. And these are the two equations. And now we have to solve these equations to find out the value of the T2 and to find out the value of B. So now we are using the gradient descent method. False parameters here, these are that is damping ratio. T1 is this value, T2 is this value, and amplitude is B. This is for the particular systems. That is a P. This is the one of the parameters in the frequency domain. And here we got through the gradient method, through the gradient descent method, and this is that method that we have used. Actually, this is the nothing but iteration method, and here we are getting that approximate value of amplitude be 2.93, and T2 is 1.8274, and T1 is already we have got, because T1 we have assumed that T1 is the value of the 90% of the rising time of the systems. Now, that is the error. Gradient value, this is the error. That error is 0.3889, and for the, that is for the gradient values for, this is for T2 and this is for B, and this is 0.005. Here we are having all those systems in this table, and here you can see that this value is not so much. Actually, it is lies between 0.5 and minus 0.5. Here it is seen that the table 1, this is the table 1, and here this value always lie in minus 0.5 to 0.5. So we can adopt that system in the engineering areas and to see that how much result we can get. This is the MATLAB simulations where we have used T1, T2, and B, and we got the simulation, and this is the result. You can see this is the deadbeat response, and you see even we have used this particular value in the table, but we have got this type of response, but there is a small oscillation still in the present in the red line still. And here this is the original uncompensated system, and here after adding the signal correction technique, using the signal correction technique, we have got this result, and this is that actual additional signal with the signal correction technique that we are using to the reference input. We are adding to the reference input, and after adding this signal in the feedback loop, we got this type of response. And but this is not exactly the deadbeat response. There have some oscillations, and it is not exactly straight. It is not exactly settled in the unit in the actual step input 1. There have some small oscillations. Now let's see that type of tuning that we have to do through using the genetic algorithm, that how better result can be obtained using the genetic algorithms for the fine tuning. And here the value of T1, T2, and B is already given. And there is another systems, and here also you will see there you have some, it is not exactly deadbeat, it is not actually tuned properly, but it is acceptable. It is more or less acceptable, but we have to use the genetic algorithm for the further improved result. Now we are using the multimodal technique of genetic algorithms, and actually genetic algorithm is not exactly the deterministic algorithms. Here we have to use some data. Data means that we have to use some chromosomes of the binary bits, and we have to minimize through whenever it will converge toward whatever the precisions we have been taken. If it meets the precisions, then we have to stop that. We have to terminate this algorithm. So this is the functions that we have to minimize. That function I have already shown you. This is the fitness. This is the overshoot value, and that overshoot value actually it is being calculated of the so over the second overshoot, and A is the actual input, and output actually what is our objective? Our objective is to that whatever input I am giving to the system, that same type of output I must have to get. And that is the nature of the ideal systems. And that actual output we have to get in a minimum time. So there should not be any oscillations, and it will be settled with the minimum amount of time durations. So here, this is that the function that we have to optimize. And here we have to use that initial values and range for the first system as shown in table 1. So starting time T1, we are having the 3 parameters T1, T2, and B. So T1, one chromosome for T1, one chromosome for T2, and another chromosome for B. So that 3 parameters, X1 means that is starting time, X2 means for the T2, and B means for the amplitude. So we have defined some range. Actually, we got it is 1.5128 and 1.8274. So I can get the range of 1.4 to 1.6 for T1, 1.6.9, and 2.5 to 4.5 for the amplitude. Now, according to our precisions that we have obtained, that the length of the binary bits will be 20 bits for the chromosome for T1, and chromosome for T2 it will be also 20 bits. It is actually that the 6 decimal places of precisions that I have considered in my experiment, and length of B is equal to 25 bits. That bits has been obtained using the precisions of our result. Now the initial value, this is the initial value. Now we have to use the genetic algorithm, and this genetic algorithm technique is called a multimodal technique of the to obtain the pulse parameter. Actually, we are signal correction. What type of correction we are considering here? We are considering the pulse signal. Now we have defined that 100 chromosomes, and these are the triplet. One is the starting time, one is the ending time, another is that amplitude. Randomly generate as usual for the genetic algorithm, that all the chromosomes first initially to be randomly generated with all the 3 parameters T1, T2, and B. And now we have to define the fitness functions. Fitness function that we have to obtain using this type of equations. We can calculate that what is the fitness value. Now the number of generation can be taken as input. The generation total, suppose we have to consider say 200 generations, we have to terminate these algorithms. It may be 400, it may be 300, it may be 300, whatever be, that we have to stop it after some large number of generations. So it may be the 100 generations, it may be the 200 generations. It depends upon the how much precisions you have to consider for the particular system. So here total number of generations and crossover rate, and this is that normally the genetic algorithm has that two operators, two operators, genetic operators are there. One is the crossover and another is the mutations. Crossover rate we have considered initially 0.6, and mutation rate we have considered 0.3. 0.3 is little more high for the mutation rate. Mutation rate should not be so high, but we have considered it is 0.3 initially. Now we have to change whenever we are getting the results, that we can change in the intermediate executions of the programs. Now there are the two offsprings that are picked up using that after using the crossover operations and mutation operation, that the two offspring will produce, and that two offspring that will produce that the parent populations, that is the usual systems of the genetic algorithm. So single bit mutations I have considered with the mutation rate 0.3. Now this is the control of the algorithm, that if the generation number is the generation, or suppose we have to stop the algorithm for the 200 generations of the iterations, then we have to stop the, we have to terminate the algorithm. And if that is equal to generation total, then we have to go for that, then generation total, then go to the step 6, and otherwise go to the step 4. Okay, so in the step 6, what happens, you see, whenever it will terminate this algorithm, all the chromosomes of the last generations are considered to be the multiple solutions. That means all the 100 chromosomes, whatever we got it through the genetic algorithms, it will give the solutions of the T1, T2, and B. Now from the 100 solution, this is the question, that what solution I have to consider, which one is the most optimum, and that is the use of the multimodal technique. these chromosomes are arranged in the increasing of the order of their fitness value. That is, the best chromosome comes first and worst last. So whenever that chromosome that we are optimizing this particular function, so best chromosome means that becomes very close to the zero. So that is called the best chromosome actually. So we have to order all the solutions, or we have to order all the chromosomes. Chromosomes means that is the T1, T2, and V. These are the three solutions that has to be obtained through the chromosomes, and we have to order in an ascending order. That the first chromosome, then second chromosome, first base, then second base, then third base, and 10th chromosome. This is the worst chromosome of the 100 out of 100 chromosomes. So that means the base 10 chromosomes we have to order in a ascending order. Now we have to calculate the Euclidean distance using the root mean square. That means Euclidean distance of the chromosome. That is that there are the three parameters. One is T1, another is T2, another is B. So we have to calculate using the root mean square formula, starting with the first chromosome to other chromosomes, other 9 chromosomes. And then again to swap the chromosomes which are closer to the first chromosome in terms of equivalence. So the chromosomes which are very close to the first chromosome, that the first chromosome means is the best chromosome, that we have to order it again. The set whatever achieved is actually the total number of solutions for solving this problem. And it has been observed that normally the first 10 chromosomes of the last generation can give the near optimal solutions of the above optimization problem. Now, best solution which matches the problem is obtained using the next algorithm. Now, which one is the best chromosome? That is the second algorithm is been given out of 10. Now, to integrate the functions mod of Ct minus a, Ct is that actually that time response of the after injecting the additional signal to the reference input from 0 to T1, where Ct is the output response from 0 to T1, let the obtained error be U1. So we have to calculate the error. One is that 0 to T1, T1 is the starting time, 0 is the starting time of the system. That absolute error we have to consider C of T minus A. That is the Ct is that actually the time response after adding this signal, and E2 is the error from the time T1 to T2, and E3 is the time from T2 to the settling time. So what is that? 3 by J omega n. And that is the actual, this is the settling time for any uncompensated system. So we can consider it as the infinity also. So there are the three errors. One is E1, another is E2, another is E3. Now E1 is the time from 0 to the time T1, that is starting time of the additional signal. E2 is the error from the absolute error from the ending time from T1 to T2, that is the starting time to the ending time, and E3 is the error from ending time to the infinite time. Okay, so settling time also here I have written the settling time, but settling time it's okay, but whenever the system to be settled, whatever input that I have given in the original system, whenever that input is actually achieved, that is called the time where the input output and input is same, that is called the settling time. So that the absolute error, that is that integral absolute error IAE is equal to E1 plus E2 plus E3. The chromosome is chosen for the best solution where IE is minimum. So this is the genetic algorithm using the multimodal technique that I have used, and after that genetic algorithm here being used for the fine tuning of the system to get the desired result. Initially we got it without using the genetic algorithm, using the gradient descent method, that is nothing but an iteration process, and we got it some result, and later that result is not always to be acceptable for all the systems. To make it more acceptable and to make it more deadbeat response in the original systems, we are using the genetic algorithm for the fine tuning. And after using the genetic algorithm, this is the table that I got it, that initially it was 1.5128 and it becomes 1.512875. That is the for whenever the generation number has been progressed, and we are getting the more input solutions of that particular system. And here you see, this is the system that we got it without using the genetic algorithm, using the gradient descent method, that is the iteration method. We got it here. And after using the genetic algorithm, after making the fine tuning of the systems, we are getting this, and this is more acceptable. That figure is very small, so it is not easily understood that how much it will be improved from the original result. But here you can see it. Here, this is the deadbeat response of this system. That is the original system. This is that oscillatory curve. And after making the deadbeat, using that type of additional signal, using the signal correction technique, we got it. This is the T1, this is T2, and this is the amplitude, that particular height. This is the amplitude, and we got the deadbeat signal like this. And it is more or less good. But here, whenever we are making the fine tuning using the genetic algorithm, you will see much better result and more improved result that we had seen it. So here, this is the use that of the genetic algorithm that we have applied for the linear continuous control systems that we have used it. And here, this is the system that we have considered it for the second order systems, and we can consider it into the higher order systems also. We can consider it. Here you can see, here this is the original system. You see that how much overshoot. This is the first overshoot, and this is the time of the first overshoot. It is around 2.4. And now, after getting that after using the signal correction technique, using some additional signal to the reference input, that we got it this type of response, and that is the actual response that we always desire in any type of systems. Here it is you see here, this is the rise time, and here it is being settled, because it is being settled in 1, because we have given the input 1 as a step input. So our objective is to get the same output whatever input we are giving, and here this is the result that we got it. But our original system was that type of oscillations was there, and it has been settled here also after long duration of the time. But here, after using this kind of signal correction technique, that it has been settled here only. So this is the use of the genetic algorithm for the fine tuning of the results to get a deadbeat response using signal correction technique. And this is some example that already we have got. This is the result that we have already got using the genetic algorithms. This is that additional signal using signal correction technique. That signal has been added into the feedback loop. After that signal has been added to the feedback loop to the reference input of the system. And so here you see, this is a quite good result of this, and always we desire this type of result after using this pulse signal which is generated using signal correction technique. And here that I have already mentioned, this is the time T1, and this T1 is the 1.7306. You see, this is the 1.7306, and T2 is sorry, T1 is 1.5147. Your 1.5147, T2 is 0.706, and B is 2. You see, this is the 4.7 particular height. So here, this is the for the second order system. Now the thing, this is the example for another system. This is the actual GN system, and the deadbeat after using that additional signal using signal correction technique, and also after using the genetic algorithm with the multimodal technique. And this is the actual circuit. This one is separately on it, a deadbeat signal. This is our design input that also to be desired for any kind of oscillator systems, always to be mostly of the systems, and to reduce the non-linearity of the system also. Here also there is another systems, and this is the original response, and this is the deadbeat. And this kind of pulse we have used it, pulse signal. This is the additional signal that is being added to the reference input, and this is our deadbeat. So this is the table that we have already shown. That is a table T1, T2, and D. But now this is the but I want to discuss about the ramp input now. That the time is almost over. So this is the ramp input. Here, this is the input for the deadbeat. This is the original ramp signal, and after using that type of response, and that this is the additional signal. But for the ramp input, for your information, we have to use that 4 parameters. One is the starting time t1, ending time t2. This is the starting time t1. This is the ending time t2. B1 is the signal, B1 amplitude that has been applied into at the starting time. B2 is the another parameter that has been applied at the ending time t2. So there are the 4 parameters. For ramp input, we have considered the gate bit. And here also we have used also the genetic algorithm in the multimodal technique to find out the gate bit response. What is to be any kind of system, any type of system, robotic balancing robot systems, that has to be more stable systems. It is not a type of oscillatory system, because we have to concentrate about the settling time of the system as soon as possible with the minimum duration of time. So that is the signal, and I am saying about that what systems. So whatever the things shown here for the second thing to consider for the third order system, for the fourth nth order system use. So what that you system never gets there. So we have to, for we are considering the third order system. That third order that systems, we have to consider another system, another dummy systems, and stop presenting. It is signal. So we have to consider, whenever we consider the higher order systems, that first we have to consider another dummy system which is equivalent to the system. So if I get the third order system or fourth order or nth order systems, that we have to consider one system that is the second order system, but second order system equivalent to the third order systems. So we have to make one dummy systems for the second order equivalent system for the third order or any higher order system. First, we have to consider the second order system, and we have to make the gate bit of the second order system using the same technique what I had actually pulled so far. And that the same signal, same additional signal we have to inject into the third order system. So our first approach is to find out one equivalent system that is of the second order system, which is very much close, or which is very much equivalent to the any higher order system. So whatever the signal to be used for the second order system to make the deadbeat response, that the same signal I will use for the higher order systems to make the deadbeat. So here also that we have done it, that also to be done. Now the question is that how to convert that third order system into a second order system. Actually, we are not converting, that physical system never can be said, but dummy system, that imaginary systems that we have to consider, that third order system to second order system, how to make that equivalent system. That also can be used using the genetic algorithm. Through the genetic algorithm can convert the third order system into another system of the second order system, and then whatever the signal, additional signal to be injected into the reference input, the same signal must to be implemented to the third order system to make the deadbeat set. So this is the work that I have done it. Now there are so many algorithms that is there, how to convert system to that second order system. Also to be done using the genetic to the optimization to reduce the pole. That is, suppose there are the there are the three poles. Three poles means one is the real pole, the other the imaginary. So we have to reduce the real pole. Not only to reduce the real pole, but also the imaginary pole. That is the two conjugate poles. That also we have to modify to make it the equivalent second order system for the higher order system. So this is my presentation. So thank you. So It's a solid
I think, sir, we're already running late. It has been a very insightful talk and a very thought-provoking too. But we will have to run to we'll have to run to the next speaker, and it is really an intricate area you were talking about. And thank you once again. And I don't think we have, even if anybody is having any question, we have the time to take up anyone. So I'm going to the next speaker, Professor Dr. Pritesh Chakraborty. He is the teaching faculty of English in Acharya Sukumar Sen Mahavidyalaya, Bardhaman University, India. And he has been associated with this teaching field for the last 10 years. Presently, he is the guest faculty at Ravindra Bharati University too. He has also been the Fulbright foreign language teaching assistant at New York University in 2019. His research areas include artificial intelligence and English language teaching, artificial intelligence and as a fictional trope, popular culture, pedagogical methods and technology, cultural studies, and comics. And presently, he is working on comics and language teaching and English language teaching and language technology. And thus today, his topic is boon or bane, language teaching and artificial intelligence. I am begging your pardon. I am just going through a very brief introduction of the speaker because we are really running late and I do not want to take any time away from the real presentation. So over to you, sir.
Thank you so much for the thankfully brief introduction. You were like stretching my limits, and I am very glad to be here. I was listening to a few speakers. Patchy network, yes, mine as well, and that's artificial intelligence for you. But I'm very glad to be here speaking amongst such luminaries, and thank you for giving me this opportunity to present whatever nonsense I'm going to speak. So I'll try to make my presentation. Just give me 1 minute for that. I want to share, present screen, start presenting. Start now. Okay, I have started to present. I think my screen will come up.
Yeah, definitely. We are already facing too many technical glitches
You,
from the very beginning.
yeah. So there will be a few glitches here as well, and I'll try my best to avoid them, but it will still come. So is my presentation visible on the screen?
Yeah, absolutely, absolutely fine.
Okay. And am I also visible and audible? I don't need to be visible. Am I
Yeah,
audible?
you're absolutely audible. You're absolutely audible.
Yeah, the less you see of my ugly face, the better. Okay, so as the topic is boon or bane, language and artificial intelligence. Um, of course, the first question that comes to our mind is why do artificial
Your voice is
intelligence
cracking,
or why
sir.
need for this? Yeah, I know. I mean, this is so horrible about the network. Is it okay now?
No, yeah, yeah, it's fine, fine. Okay.
Okay, all right. It will be cracking in between.
It's
So
all
if
right, all right.
all the
We will
bleeding.
try to bear with the situation. We will try.
Okay, all right. Thank you. Please bear with me. So the need for this AI has become all the more immediate because of the situation that we are going through. So here's this little thing that warms us up as teachers. Like I will teach you in a room. I will teach you now on Zoom, though we are on a different platform. I will teach you in your house. I will teach you with the mouse. I will teach you here and there because I will teach because I told you very briefly and technical glitches because we cannot go person to person because we cannot go face to face. We are in the need of artificial intelligence all the more. Um, As this picture represents, due to the COVID situation, most of the teaching has to be taken online. The platforms have changed, the game has changed, and people who will not make this switch will might lose out in the long run, as we can see in this picture. So there is a clear shift of paradigm from offline to online teaching, where artificial intelligence and computers and machines will play a very important part. What is artificial intelligence to begin with? I mean, all of you are very well aware of the basic definitions of artificial intelligence, and I would be just repeating whatever you already know, but assuming that we might have some people here who might like to have a small introduction to artificial intelligence. So, according to Patrick Winston, the Ford Professor of Artificial Intelligence and Computer Science at MIT, artificial intelligence are algorithms enabled by constraints, exposed by representation that support models, targeted at loops that tie thinking, perception, and action together. Again, while addressing a crowd at the Japan Artificial Intelligence Experience in 2017, Data Robot CEO Jeremy Atkin defined artificial intelligence as a computer system able to perform tasks that ordinarily require human intelligence. Many of these artificial intelligence systems are powered by machine learning. Some of them are powered by deep learning, and some of them are powered by very boring things like broadly speaking, artificial intelligence into strong and weak. We will not go into these technical details because I'm more of a language and literature background. I do not possess normal intelligence, and I should not speak much about artificial intelligence per se. So I will jump directly into my area where I will be feeling more comfortable. So we are dealing with language learning. So I will try to make a very a broad distinction between language learning and language acquisition. Now, acquisition is something that is automatic. Acquisition is something that is home based. Acquisition is innate, as opposed to learning, as the chart represents. If you see directly under the language acquisition begins from the fetus, from 3 months, and continues through first year, second year, third year, so on and so forth. So what Mahabharata said, that Abhimanyu was learning how to fight while he was in his mother's womb, might just be true. Who knows? Anyway, so acquisition usually takes place like unmonitored, unfacilitated, but language learning is facilitated. Language learning is monitored. Language learning is institutionalized, and learning can also take place from 2 years and so forth. Learning can lead to acquisition, and acquisition can reinforce learning, but we will be talking mainly about how artificial intelligence helps in language learning. Okay. Now, these are the four basic skills of language learning, language teaching, if you say. Uh, Priyanka, do tell me if I am breaking up or I'm not audible, so that I'll like repeat something which is more important and then
No,
gloss over
no, no,
something.
it's fine. It's very clear. It's very clear. Absolutely fine.
Okay. Yeah. Yeah. Wow. Okay. All right. So, listening is is put at the top because most of us learn languages, whether they are first language, mother tongue, or they are second language learning. In this case, we are focusing on how language learning can be facilitated. Language learning of English can be facilitated by artificial intelligence. So, listening, speaking, reading, writing, all these four skills of language learning will be facilitated, will be supported, will be augmented by artificial intelligence. And in my slides, I'll try to show how all of these skills can be augmented, can be facilitated by learning, so artificial intelligence. Now, what are the challenges to language learning? And now, when I say these, when I'm mentioning these challenges, I am using my personal experience with second language learners in India. Many of them were first generation learners, which makes things very difficult. But this is my experience of teaching language, teaching English as a language. The first problem that comes up is sociological or cultural. The second is emotional, psychological. Third is technological. The third and fourth are more or less equal in their impact, technological and logistical. And the fifth is physical or physiological. Let's try to have a more detailed view of these impediments to language learning. The first is the sociological or the cultural impediments to language learning, and in the later slide, we will see how AI can help. So, what are the problems? If you can see at the top right corner of your screen, then there's this classroom where the teacher is trying to teach, but there is a huge burly guy sitting in front, resembles something like me. I'm fat like that. But the people who are at the back benches cannot see because of poverty. Now, if this happens, if this is offline cases, imagine the situation that will happen in the online cases. But we will see as to how AI can help. The second problem, the second impediment is gender bias and some cultural issues which are averse to male or female teachers in certain situations. So the second picture is representative of how difficult it is for a female, for a woman, especially in our country, to go ahead and learn, whether it be language, whether it be something else, whether it is corporate. Everywhere, women face a lot of bias, a lot of difficulty. Then there is the inaccessibility of the learners due to difficult terrain. Now, here is a representative image of how students have to undertake perilous journeys to travel from their places, from their abodes to the temple of education. A ride in Kolkata buses with its broken streets is equally dangerous, but I have not used that. Okay, and then there is government apathy. The government is, as we have seen from our experiences, has been not really forthcoming in helping out where the help is really needed. There is also a problem related to how government handles the problems of education. Now, how can AI help? Solutions to problems by artificial intelligence. First, sociological or cultural impediments can be solved by artificial intelligence in the following manner. Number one, poverty. We can use mass interactive modules like smart boards which are used in many Western cities. They could be costly to buy or maintain, and security would also be a matter. But uh, if we can install them at places where children can easily reach, I mean, we can install them in the localities, in the mofusils, in the rural areas, and these interactive boards, touch boards, can provide a lot of real-time information to the children. But of course, there is a problem of the security of these machines because somebody might think that they could uproot it and take it home. Second is the gender bias. Well, artificial intelligence does not discriminate. Since it's a machine, it can teach both boys and girls, and I hope people who are averse to female or male teachers in certain environments will not disagree with Alexa or Siri when they teach something, because after all, it's a machine. Now, inaccessibility. Artificial intelligence can reach anywhere. If the students can't reach the school can reach the students. Can be fixed anywhere. Still, it will need technicians to fix any problem, or power sources would also matter. And government apathy can be overcome by private players. So as we can see that most of the telephonic networks all across our country is working well, so efficiently, and though there is a government agency called BSNL, but the private players are making it more, making telephony more accessible to even to the rural areas of our country. Um, the second problem about the second impediment to the educational proliferation is emotional or psychological. The first one, according to me, is this colonial hangover about the language English. People want to think this language to be elite or something that is responsive of status or something like that. Secondly, and this is a real problem, like while I'm speaking, I know many of you are taking your WhatsApp messages and your Facebook status, and somebody is taking a selfie, I don't know. So goldfish now have a longer attention span than that of the average consumer or the average human being, and that is true. So short attention span from the students is a problem, and teachers here would agree, would all agree, I guess. Third is peer pressure. Uh, the kind of pressure that is there on the peers while learning a language can make a language learning a very painful process. I had similar problems learning mathematics. Like everybody was doing mathematics correctly, and I was dumb, and people made fun of me. So I was like very scared of mathematics. Still am. Okay, so the fourth is that the fear of failure or performance anxiety. Many language learners cannot perform well because they are they are so anxious about performing well. I mean, I am anxious about performing right now in front of you with a patchy network, and I could like stammer sometimes because of that. And then there is the lack of motivation. There should be a proper motivation, which often lacks in the cases of many language learners and language teachers. Now let's see how AI can solve these problems, if it can. uh, Number one solution to the problem about the colonial hangover is that AI can become more native friendly, thus countering the colonial hangover. If you can see to the left of your screen, top left, Sophia, the first robot citizen, is wearing a sari. That creates a kind of a familiarity within the language learner. And if you are a machine, if you are a neural network, you can take over any form. You're like a god now. You can come up as anything. I mean, I had this idea, like why not make a conversation between a learner and the artificial intelligence, where the artificial intelligence takes on the voice of that learner's boyfriend or girlfriend. That makes things really very interesting. Next is the huge amount of variegated data, audio, visual, interactive. These can make learning interesting. Uh, AI can like bring in thousands of pictures, thousands of images, thousands of videos, and various kinds of interactive ways in which AI can make the classes interesting. Then no peer pressure to learn at ease. Like AI is not going to like laugh at you because you are pronouncing English in an improper way or a non-standard way. AI is not going to make fun of you in front of the whole class, which many teachers sometimes do, or peers sometimes do. Next, machines aren't judgmental and no emotional torture. Non-human, however, non-human participation might dampen the spirits. Now, let us look at this video, but I don't know if this video would play. I'll try to play it, but I will explain what I meant by huge amount of variegated data and the image at the right of the with an elephant in it. I will try to explain why I have no, it doesn't. Thank you, AI. So this was the video of a Mondly augmented reality, which creates virtual environments. A similar virtual environment is used in Kerala classrooms. If you can see the bottom image, there is this elephant in the classroom. This elephant is not real, of course. This elephant is augmented reality, and the teacher is using this augmented reality in a classroom to teach what an elephant really looks like. Just imagine the implications of that. 3D imaging, even palpability of these images is a huge boost to the learners. Now they will be so very well grounded in the context of what they are going to learn, and we will come to context in our coming slides. Um, Next is the problem with the next is the technological challenges in front of the people who are going to learn languages. So language classroom can be technologically challenging, as the first image tries to present. The computer and the person is trying to say the same thing, that can't you do anything right. I was cursing my internet network, I was cursing my laptop for not doing things correctly, but maybe I was doing it wrong. Artificial intelligence or language learning can be a new literacy altogether, and this can pose a real problem, a real threat to language learning. Adaptability issues by the elderly. The elderly person in the picture is really not happy with what the computer is trying to tell her, and this can be a real problem with many people. My mother sometimes sends the videos of nothing in order to communicate with me. I try to understand that she was trying to record a video or a voice note, but all I see is like zzz, things. So next is the data delete, of course. When you are on internet, and this is one of the reasons for the short attention span, the students are really very much distracted by the huge amount of data that comes into them. So there is a question, there is a problem of data deluge. Again, adaptability issues by the differently abled. The differently abled will not be able to use artificial intelligence, which is again basically constructed for people who are not differently abled. It can lead to a number of biases, it can lead to a number of imperfections of learning between the not differently abled and the differently abled. Let's see how AI can solve them. Number one, AI is flexible, can be learned at self-pace. So grandmas and granddads can learn it at an ease, can learn it at slowly. There is no hurry to learn them. There is a different. There are a number of ways in which AI can become more flexible and customizable to the needs of the people, whoever is using it. Portable devices can be used. Well, earlier there was this computer which was room full, and then now we have handheld computer devices. This mobile through which I am trying to communicate seems to be working like a computer. Now, this is important. Homework and assignment evaluation can be done by AI. Now, isn't this music to the ears of the teachers? We spend a lot of time looking at the homework and the assignments that we have burdened our students with by checking them, trying to evaluate them, trying to correct them. AI can do it in a jiffy. It can be used to rate assignments for the students according to the levels of proficiency or learning techniques. This analysis will be done by the AI, giving more time to the teachers to engage with the students. Now, this will be a real thing. Like, if we do not spend so much time trying to create vocabularies for them, trying to understand whatever gibberish they have written, AI can understand any writing and can like analyze it, can compare it with whatever exists in English language, and find the thing that the person was trying to write, which is quite difficult for human teachers to do that. When AI these kinds of things, the teachers can spend real time with the students. Now, AI can manage and customize data, which it already does, like Facebook and other mediums. Now, I'm talking about the data deluge. That is a technological problem that language learners often face. What to take from the language class. Now, AI can target specific areas, specific data, which the language learner can get, and the AI can highlight it mentally or physically for the learners in order to understand them. The AI can understand which category the student belongs to. Like, is he a novice? Is he or she a novice, or is he or she is a beginner, an intermediate, an advanced, or a superior? These things can be analyzed from the responses that the students are making, and making not just in a kind of a 6-month semester, but also daily basis, because a teacher will not be able to understand a student or evaluate a student just by going through the single day data, which the AI can do. Now, for the differently abled, for people who cannot see, there is this AI enabled machine called Haldia 3 that can literally help the visually challenged people learn through sight, through vision. And you can check it up in the Google as to how it works, but it is really revolutionary as to how it transforms any kind of data, touch data, auditory data, visual data, into understandable visual or non-visual data for the people who are visually challenged. Now, another problem that comes up while trying to teach language is pedagogic. The first is the lack of context, especially in grammar. I mean, I don't know if there are many language teachers, English language teachers in the audience, or whoever is listening. Grammar is usually taught in our schools out of context. Ram is always a good boy. We don't even know who Ram is, why is a good boy, what does good mean here. And in the similar vein, we can see this dinosaur in the city. What is the dinosaur doing? And how is this dinosaur taller than the city scrapers? Well, there you go. The context goes for a toss in a grammar class. Applicability. Now, we have learned a language, but we do not know where to apply it, where to use the words. So that is also a problem of language learning, because if you do not practice it much, then you cannot really apply it at particular places where you need to. Lack of relevant content. There is a lot of content, as I was saying, data deluge, but there is lack of relevant content. Lack of exciting content and technique can make the students feel bored, as many of my listeners might have become already bored from my continuous droning. Okay, but what are the pedagogic solutions? Now, huge amounts of virtual contexts can be created through bots like Chatterbox, and visual reality like bazaars or tourist spots can be created. Applicability follows content oriented solutions. Like, the AI can give you real situations like these bazaars and these tourist spots where you can continuously practice, and the situation can change like games as you go through various levels. And there you will find a new situation, you will have to come up with new context, you will have to come up with new syntax and words. AI, by analyzing big data, can find the relevant from the irrelevant. For example, the inferotemporal, the IT cortex, is capable of performing tasks such as distinguishing words from nonsense words, or picking out specific letters from a word. And AI can reduplicate it. AI can mimic this inferotemporal cortex into doing similar things. Now, solving learning and other physiological disabilities. As you can see in this picture, there are these two scientists, and these people are doing an experiment, and I'll read it out what the experiment is all about. This happened in 2013 in the University of Washington. University of Washington researcher Rajesh Rao, left, plays a computer game with his mind. Across campus, researcher Andrea Stocco, right, wears a magnetic stimulation coil over the left motor cortex region of his brain. Stocco's right index finger moved involuntarily to hit the fire button as part of the first human brain-to-brain interface demonstration at University of Washington, and I'm talking about 2013. Imagine the implications today, 7 years later. Now, this is the image of the brain, and the colored areas are the various areas which are associated with language learning. The blue area is the Broca's area, which is associated with word production, production of speech, the important part of language formulation. Then there is Warnick's area, which is colored in green. It is word reception center. It understands speech. It works with angular gyrus, which assembles information, so on and so forth. Now, why is this image here? This image is here to tell you that AI has now developed the capabilities, and I'll tell which AIs have been able to do this. Have grown these capabilities to target these particular areas for slow learners, or for speeding up the process of word reception and word formulation and word creation, so on and so forth. Now, this experiment, or this brain imaging, brain mapping, went on at the Martinos Imaging Center at MIT, USA. And Ziling Shen, in his paper Opics and Trends in Artificial Intelligence Assisted Human Brain Research, says this: human brain research aims at achieving understanding of the structures and functions of human brain. Artificial intelligence revolutionizes modern human brain research by its tremendous repertoire of technologies and accumulative discoveries, while addressing issues about the human brain. And just below this particular paragraph is an AI program known as START that answers questions using natural language based on the responses that these Broca's areas and the Wernicke's areas generate when certain particular neurons are hit at these particular areas. Um, and this is something that I tried to compare between what happened in the PK, if you have seen this movie in which Amir Khan was there, and whatever happened in the Washington University in 2013. Well, the internet was a way to connect computers, and now it can be a way to connect brains. So said, we want to take the knowledge of a brain and transmit it directly from brain to brain. Research and in this case, the researcher controls colleagues' motions in the first brain-to-brain interface, and this was quoted in Dory Armstrong and Michelle Ma's News and Information. I will try to play the video, but I don't think it will play, but I'll still try. No, it doesn't. So if you have seen this movie called PK, Amir Khan understands language from a Bhojpuri person by just holding her hands. And while we thought it was fiction, it had already been done way back in 2013. So what if artificial intelligence can do away with the entire paradigm, entire machinery of language learning through these traditional ways, and we can learn language from each other just by holding hands, or even not by holding hands, because holding hands in the corona situation could be troublesome. This was again another video which showed, like, with empirical details about how the human, how the monkey which was in the experiment could respond to electronic signals sent by an artificial intelligence directly to its brain to function in a particularly meaningful way. But as this video unfortunately will not play, I'll try again. It doesn't play, I will not be able to show it. However, if you are interested, you can ask for the links to these particular YouTube videos, and I can try to provide you with these if you're really interested. Okay, so now let's come to towards the concluding part of this presentation, and I will try to summarize as to how artificial intelligence can help in the language learning process, because it is diligent, it is untiring, well, of course, depending upon the battery life. It can create virtual worlds like bazaar real life situation, will help the learners learn better, more context. It's non-judgmental, it's conducive for physiologically challenged people. It needs no physical space learning, no physical space. Learning can take place anywhere. Well, an extreme solution, as I already pointed out, is like getting rid of language altogether, and implications could be huge. I mean, the sky is the limit. I mean, just imagine the search and rescue operations after an earthquake. And on a funny note, husbands and boyfriends cannot lie or cheat once the brain is connected. Then it could make the world understand each other quite better. The faster means of communication will result in speedier globalization, leading to greater requirement of language learning and cultural engagements. And the data deluge is not a solution, but rather a problem. And it could lead to data deluge. But this global learning, if we thought that language learning artificial intelligence can take away the job of language learning itself, think again. More exposure to more languages will mean more learning exercises. But there are areas that needs to be developed in the artificial intelligence arena, and that is the gestural. The body language matters a lot. I don't know how Siri or Alexa or the Google Assistant can behave in a real world. They don't have empathy per se. They can hardly improvise in very complex situations, which only the human brain can. And like computers, AI should be made familiar, like the language of the AI should be taught regularly. Regional voice modulations are necessary, which is a post-colonial problem. Artificial intelligence cannot still understand changes in the mood, and things are underway to do that as well. AI is a language in itself. To learn a language, one has to learn AI. And is it only for the rich? That's a huge question. Like, can the rural people, can the poor people afford this AI? Will it create a new class of oppressor called the technocrats and technocracy will reign? We don't know. Language or our voices were something that was unique to us. Could it not be duplicated? But if it can be, then what will happen to the kind of voice cloning or the authentication by voice or something like that? That's a problem. Now, could AI replace language teachers? That's the real bone of contention. Well, it is not a good scenario in a country where a large chunk is unemployed or underemployed. I don't want to lose my job to AI. And translators might also lose their jobs. Google is not doing a very good job of translation, but it's learning, and translators beware. Nick Bostrom, 2014 bestseller, Superintelligence, Paths, Dangers, Strategies, wants that AI could spell the end of humanity, like literally, as it happened in the case of this movie called The Terminator, where the artificial intelligence machines destroyed humanity altogether. Now, you might find it quite awkward because of this image. Now, this image was the image of the biblical image where the knowledge was transferred through a fruit. And remember, apple represents this kind of eaten fruit. I do see a link, sinister. So what happens when the knowledge, the real knowledge, the deep knowledge is transferred to the artificial intelligence? Will we also, who have created artificial intelligence, will be rebelled against by our own creation? Might happen. Now, another IBM researcher turned e-marketing CEO, Louis Del Monte, in his 2013 book, The Artificial Intelligence Revolution, Will Artificial Intelligence Serve Us or Replace Us?, agrees that artificial intelligence is happening so fast that the changes could be cataclysmic. The National Geographic writer and filmmaker William Barat, too, joined the fray in full apocalyptic mood in our final invention, artificial intelligence, and the end of human era. Some AI engineered language learning apps, which you might try to use it in your everyday language teaching classes, are mentioned here. They are Intellas, Duolingo, Mondly, Andy, Lanny from Eggburn Education, Memrise, Rosetta Stone, and Babbel. You can take a screenshot of this and try to find them in the Google, and some of them are free. So let me try to conclude. Thank God it's coming to an end. They need my bones to make a city of stones. They need my eyes to shine in the sun darkened skies. And this is a post-apocalyptic, fully AI-controlled environment. So I already pointed out these the scenarios of what can happen if we do not take control or we do not use our discretion in maintaining our relationship with the AI, which I do not want to repeat anymore. So I'll just say thank you for listening. If you are really, really listening to me, thank you for listening for so long. If you have any questions or suggestions, do write at this email ID if you can see this. Thank you so much. That will be the end of my presentation, and I'll try to not present anymore. And
Thank you so much, sir. for so nicely addressing the current problems today several English teaching teachers are facing while trying to input lessons online to the students and also trying to use various technology language technology to speak more specifically. And we all know, as you are saying, that in this COVID-19 situation, in this when we all are locked in the room, schools have already been shut, and we are having classes online only. So here also, as today also, you have been facing so many technical glitches. We are running nearly 30 minutes late. So you very nicely addressed all those issues. Thank you so much. I personally had several questions, but no time. Professor Willing Ding is already waiting. I'm really sorry for that. But thank you too for your interesting talk and the way you have tried to associate even the eating of the forbidden fruit with AI. Very nice, very nice. Thank you so much.
Thank you. Thank you. Thank you so much. Thank you.
And with this, I would like to go very quickly. And ma'am, I'm really very sorry that we are running 30 minutes late and we had nothing to do. So now we have come to our last, but one of the most interesting speakers. For all have been really very interesting, no doubt. For today's session, this is Professor Willing Ding, Professor of English Rhetoric and Technical Communication in North Carolina State University, United States of America. She is the director of MS in Technical Communication program and faculty member with a PhD program in Communication, Rhetoric, and Digital Media at the North Carolina State University. Ding is the author of the award-winning book titled The Rhetoric of a Global Epidemic, Transcultural Communication about SARS. We can definitely go for this book. I think all have gone also. Which received National Council of Teachers of English Conference on College Composition and Communication 2000 Best Book Award in Technical and Scientific Communication. In addition, her articles won the 2013 Nell and Pickett Award for Best Article in Technical Communication Quarterly and the 2008 Editor's Peak News Scholar Award from Written Communication. Her research areas mainly focuses on artificial intelligence and risk communication, technical communication, intercultural rhetorics, risk rhetorics, medical rhetoric, digital rhetoric, writing in the disciplines, health communication, genre studies, ethics, and social justice. And to read out just a few research papers very fast, she has many, I'll not be able to finish it, but it's just a part of the formality. Constructing in artificial intelligence in the US and China, a cross-cultural corpus-assisted study, general analysis of personal sentiments, analysis of moods in application ACEs to medical and dental schools, the use of cognitive and social apprenticeship to teach a disciplinary genre, initiation of graduate students into NIH grant writing, rhetorics of alternative media in an emerging epidemic, SARS, censorship, and extra-institutional risk communication. Many are there, and she has got several projects also undertaken, but I'm not getting into that. Today, I'd request her now to start her speech on artificial intelligence and job screening.
Thank you, Dr. J, and thank you, the organizing committee. I'll turn off my camera so we have more bandwidth for the screen share. Okay, great. Thank you. Good evening, everyone, and it's an honor to be here tonight with you. And today I want to focus on job search 2.0 in algorithmic world, and we'll focus on AI augmented screening. Can you hear me? Can you hear me well?
Yeah.
Oh, okay, great. Thank you.
Fine.
Just want to make sure. Okay, so great. So most of the presentation today was funded by a grant from National Science Foundation that focus on AI and the future jobs. And so I'll share some of the case studies that we did with AI and job search and recruiting technologies before we talk about teaching and pedagogical practices in general. So I'm sure you've been paying attention to this and maybe even affected by part of these technological changes. But the job search world has been radically changed in the last 2 to 3 years, I want to say, especially in the US with AI augmented screening. And today, what I want to focus on will be number one, resume passing technologies. Number two, job matching used by companies such as Chili and ZipRecruiter. And then the third one will be the automated video interviews that serve as the first round of screening of job candidates now for a lot of the larger companies. So we can start with traditional hiring. When you think about traditional hiring, right, the entire workflow looks like this. So we will be submitting our maybe one-page resume and a cover letter to a HR division, right, human resource division. And then the HR personnel will be screening the resumes and cover letters. They come up with a short list and they invite them to the first round of interviews and then maybe going through a couple of interviews and eventually through those human interaction, human screening, one of those top candidates will get the job offer. And for those of you who are also teaching maybe writing classes, especially workplace writing, professional writing, we teach students how to produce employment projects focused on resumes and cover letters, and then tell them how the resume screening process work in the office, HR office, and then we prepare them for job interviews by talking about possible questions that may be asked and best strategies to go about those challenging questions, and then how to negotiate the job offer. And in the last 10 years, one really interesting genre that was catching a lot of attention in employment projects was the use of the so-called video resumes when job candidates try to go beyond the one-page resume and talk about themselves, who they are, their skills and qualifications and personality, right? They want to give a personal touch to the job application. And we also read quite a few reports about how those video resumes actually really helped the candidates in the job search process. So that's maybe the updated employment project back in the last 10 years. And today, in the last 2 to 3 years, the automated hiring technologies has been changing the game radically. So our resumes and cover letters usually doesn't even matter, right? They don't matter in the automated screening process because it's a resume that will be posted to job search websites such as LinkedIn or Indeed, right? And then our resumes will be screened and evaluated and ranked by what we call the automated resume screening technologies before their algorithms come up with a short list of candidates that will be passed on to the HR, and then the rejection rate at that time would be about 70%. So 30% of the resumes will be forwarded to HR, and then the HR department, will probably invite a part of those, some of those 30% of candidates to automated job interviews using video interviews through third-party service providers. And then depending on which service providing company their HR division is working with, 3 to 5 candidates will be the shortlisted ones, and they will be eventually invited to a face-to-face or for now maybe video, right, human evaluated video interviews, and then that will lead to the job offer. So their entire workflow has been changed, and their evaluation criteria has been changed, and there are a lot of black boxes in the process of job search. And we also want to highlight how the the way that we work has also been radically changed, right? For those of you who have been here long enough, you may still have the luxury of lifelong employment, maybe like me as a tenured or full professor at a university. But for the younger generation, the average tenure for them in a job, at least in the US, the data shows that it's a little bit shorter than 4 years. So for anyone who's now 18, between the age of 18 and 48, they will have an average of 12 jobs. And then what happens when we get to the 50s, right? There's no data. So there will be more challenge in that age group, for that age group. And then adding to this challenge of a lot of job changes, career shifts, and even cross-sector job changes, right? The automated screening process and technologies also add more challenges by basically rejecting 70% of candidates before passing any of the materials to a human screener or recruiter. And those technologies include automated recruiting or screening tools such as what we call active applicant tracking system or resume passing technologies, job matching technologies. And then we have video interviews and then neuroscience games. I won't touch upon those last two things today, but those are additional screening mechanisms that have been used in the job search processes. And the last one is social profiling. So basically, I'll talk about that very briefly. The algorithms will not only look at what we submitted to the recruiter, but also screen their social media and the internet to find whatever information that's out there about us as a candidate, and then present that as part of their summary to a human recruiter. Okay, so we'll cover the first two topics. So to summarize, right, we start with the big problem faced by HR and job seekers in general. Because of the wide use of recruiting websites such as LinkedIn, Indeed, Monster.com, and so on and so forth, we have hundreds of them. Candidates start to send more applications, right, to more jobs because of their ease, right, and the convenience. So the HR divisions in general, even recruiters, their workload has been increased. And they need to screen all the job applications much more quickly, and they need to hire more quickly because the average cost of one replacement of a position is about at least $3,000 to $4,000 per person. And the more time it takes, the more expensive it costs, right? The cost is. And then the recruiting process can be slow because of the legal compliance issues, right? HR procedures. So those are all the problems the HR will be facing while they want to move quickly and recover the workforce more efficiently. And then, so as a response to all these problems, AI tools has been invented, right? Using job ontologies, artificial intelligence, natural language processing, natural language generation, big data, semantic webs to help the HR, right? That's a big market. Billions of dollars are or have been invested or are being invested to make that happen more quickly, more efficiently. However, in the process of automated recruiting, we have all kinds of concerns, right? We all know that biases are built into algorithms, right? And then when our resumes and our video interviews become part of the big data without even the consent from us as the user, our privacies can become invaded. And then there's also discrimination in terms of ethnicity, age, gender, and so on and so forth. So it is important to look at those technologies and to examine how we, the job seekers and future workers, will be impacted, along with how employers are using those technologies. So I'll talk very quickly about the AI tools that we will cover in the resume and job matching processes. So for job ads, we have a lot of companies working with millions, hundreds of millions of job ads as the big data, right? And they'll be tagging and extracting keywords from those job ads for different sectors, different job titles. And then those keywords will be filled into a database of XML or JSON. So you have their ontology of different job titles related to different job titles. And then from us, the job seekers and employees, our resumes, whether it's submitted as attachment or whether it is presented as our LinkedIn profiles, right? Those are used as text to data. Again, the keywords will be extracted to build another database of, for instance, experiences, skills, credentials, and so on and so forth. And then the resume person company will also generate texts after analyzing individual data, individual resumes, and then present a summary of our resume and credentials as something that's based on customized templates. And eventually, these service providers will be delivering summaries of our resumes as customized text to output to employers or to job recruiting companies, right? So in terms of resume passing and processing, we will take Chile as an example. And then in terms of job matching, we will focus on ZipRecruiter, which is the #1 job matching service providers in the US. So once we have their job ads, right, ontologies, and then we have resume data, what service providers such as ZipRecruiter or Indeed, right, those big employee recruiting companies, employment companies, they will be doing what we call semantic matching before they rate the candidates and rank the candidates and then make that shortlist available to employers. Okay, so we'll start with Chile and how resume passing and ranking is done. Chile has quite a few, white papers, technical marketing papers, and some user tutorials released at various stages of its development. So one of the really interesting technical tutorial that they released a couple of years ago deals with resume passing. So basically, they talk about how they go through resume passing and then semantic matching and then enrichment of candidate summaries. So we'll go through that. So to start with, resume passing is done through the use of an AI tool that will extract important parameters from job descriptions of employers and then match it with their attributes that they gather from candidates' resumes. And we have a lot of columns, right? If you imagine this to be a columns of keywords, it can contain years of work experiences, right? Skills, locations, job titles, education, certification, so on and so forth. Okay, so the procedure works like this. Actually allow recruiters or employers to bulk import the resumes for passing, right? So we can upload our resumes. So for HR division, we can zip up maybe thousands of resumes and upload to their database, and then it will break everything down for us using 80 plus fields, focusing on things that are more important to particular individual, like individual employers, right? And what's really interesting is, in addition to technical skills, qualifications, experiences, they also focus on soft skills as well, social experiences such as communication, interpersonal, right, leadership skills and experiences. Okay, and then they will do the matching, and then they'll be using the template to generate a summary, and we'll walk you through that again. And the employers can come up with their own taxonomies, right? For my job, for instance, technical communication. And for instance, for this employer, right, it is really important for my new hire to know data and XML, right? So we will highlight those as must-have, right? Technical skills that will be either yes or no, right? If the candidate has nothing, no references related to those two terms, they will be rejected automatically. So the employers can customize those words. And for Chile and for a lot of other companies, they have a huge database of skills and job taxonomies and soft skill keywords, right? As you can see the numbers. And for soft skills, the numbers are almost the same. For LinkedIn, I think they have 1,200. And then for Burning Glass, they have, again, another 12 to 1,300 soft skills. So it's pretty standard in terms of agreement, right? So it's pretty reliable how we define soft skills. Okay. And then when we move on to semantic matching, one of the challenges, I think, for natural language processing in general is the ambiguity of language, right, and terms. So how do we deal with different ways of referring to the same skills or technologies, right? How do we make sure we do that correctly? And a lot of those service providers talk about how they identify synonyms and a range of ways or expressions to refer to the same thing. For instance, project management, right? It can be project leader, it can be management of team, it can be time management or deadline or budget management. So actually would be grouping those terms together as possible references that will be related to project management. So multiple keywords, right? Cluster of references. They also talk about how, in addition to relying on specific job terms and job titles, they also use a wide range of job titles that can be related to that one job that the employer is looking for. So that's how they do semantic matching. And then what's really interesting is they started to do more of social profiling. Okay, to make sure, because we all know when we look for jobs, we really need to make sure that our social media profile and our online information is clean, is professional, right? And we all heard, hopefully you've all heard of horror stories, how one Facebook photo showing someone who is drunk or in some kind of wild parties got rejected, right, by employers. So this is where social profiling comes in, when all those recruiting companies and resume and job matching service providers start to have surveillance of our online information. It is critical to pay attention to those, right? Any public profile data from LinkedIn or Facebook or Google will be probably picked up by the algorithms and then will be summarized as either, something that we need to highlight, right? Or something that may really damage our chance of getting referred or getting included in their shortlist. Okay, so that's social profiling, and that's also called resume enrichment. Okay, so eventually, service providers such as Chile will produce one output, which is called candidate summary, and depending on which level, right, they have different levels or types of information that can be customized by the clients, and usually in those summary statements, the employees' information such as top skills, credentials, right, qualifications will be summarized, and then use a natural language generation summary of past data or social profiling results will be generated as small paragraphs, right, as an end product delivered to employers. Okay, so that's the Chile and in general resume pattern. What's going on with our resumes, right? What will happen to our resume? How is it analyzed, ranked, and graded, scored? And then we'll talk about ZipRecruiter, which connects employers with employees. So ZipRecruiter is the number 1 job search app, and what they use is the so-called ATS applicant system. So again, they have something that's very close, right? Very similar to what we have just go over. So tagging, keyword extraction, template production, and then they'll have matching and ranking as part of the main business. What's really interesting about their rubric or their evaluation criteria for ZipRecruiter is, in addition to other face value, right, information from resumes or social profiling, they also have another filter, which is resume freshness. So basically, how long this candidate has been on the job market, right, is something that they look into. The longer a candidate stays on the job market, the worse their chance of getting ranked high will be. So that's something we need to pay attention to. And then the applicant tracking system, at least for ZipRecruiter, we have analysis of the job ads and resumes and the evaluation, right? Once we have their resume broken down into over, 80 categories of information, and then that will be where their matching with the job ad, right, will take place. And then their candidates or the resumes will be scored. And then what's really interesting is if we are not using our LinkedIn information, right? If we are still using their one-page resumes, something can interfere with our chance of getting evaluated more objectively. And the malfunctioning, right, factors include, for instance, visual part, right? When we think about it, resumes are used as textual data and only textual data. So anything like small margins, right? Images can be confusing. Fonts that are not recognizable by the website. Okay, so those are the things we need to pay attention to. And then profile augmentation. This is more recent. In the past maybe 1.5 years, a lot of discussion has been made about how resumes are not reliable indicators, right, of one's skills or potential. And then there's some research going on in terms of how can employers and recruiters better identify candidates who may be strong when they make career shifts, right? For instance, some of the emerging jobs such as cybersecurity or data science, right? They may be looking for candidates who are really, numerically minded, shall we say, and then they will use internships and even apprenticeship programs to train those candidates. So that's why there are discussions about going beyond the resumes, how limiting the resumes can be, and how limiting the job ads can be as well, right? Because what's stated on the job ad may not really reflect what the employer really need. So it's a lot of really interesting psychometric research going on about identify hidden skills and personal strengths and interests and help them to make that career shift, make that jump. But we don't really have anything that's ready and launched onto the market now to do this type of psychological analysis in terms of career shifts or untapped potentials. Okay. So I want to summarize how applicant tracking system and the resume pattern works, right? We have job ads, and then we have resumes, and then there's a matching process, keyword extraction, right? And then keyword extraction and then job matching. So for us, the job applicant, we like for our students, we will emphasize you really want to make sure you know what's going on in the job ad, and then really make those connections, those showing your skills, relevant skills in context, right? Describe what you've done, and then maybe that will help you to market yourself better in the job search world. Okay, the third type of technology I want to cover today is automated video interviews. And HireVue is the #1 service provider in the job market now, in the marketplace now. So what HireVue does is, so basically, they function as a third party, right, video interview / evaluation platform. And the user they have two types of user interface. The interviewees will go through a few interview questions, and they will be using the video cam to record the interviews. And then the employers or interviewers, right, will see a lot of AI evaluation in terms of using face recognition tools, right, to show, okay, eye contact and confidence level and the intonation and so on and so forth. And so when we think about evaluation of video interviews, the data comes from both our content, right, textual, verbal responses to questions, and then there's also focus on intonation, facial expression, right, a lot of, again, psychometrics, okay, and word of choice. So once we, as a job candidate, submit our video interviews online, the service providers such as HireVue, they will actually, in the back end, they use video interview responses from top performers in the job, in the different occupations as their benchmark data, right? And then they will extract key features and then compare responses, video interview performance of job candidates with those top performers. So that's how they evaluate. Okay, so when we think about it, video interviews definitely save a lot of time and money, right? Instead of having face-to-face, on-site interviews, now employers can offer video interviews to a much number of applicants, so they can broaden the applicant pool in that way. And then there's a claim that using algorithms will avoid subjectivity, right, biases. Okay, so to some extent, the evaluation process is standardized, right? And then to some extent, some of the biases can be reduced. However, there are also concerns. How are those video interviews evaluated? There's really, there's a lack of transparency. And for job candidates, I had students who came to me complaining, Dr. Dean, I can never pass video interviews. Why? Right? And that person can be a non-traditional students who are in their, for instance, late 40s, early 50s. So is there ageism involved? Is there age discrimination involved? We don't know, right? So there's lack of transparency. And then how relevant are those benchmark, right, criteria? We don't know. So there's a lack of explainable, right, AI there. And then what are the confounding variable factors, right? Lighting, will someone with a darker skin color be evaluated less effectively, right? And then how representative are the top performers, right, in terms of being the criteria that's held against everyone? We don't know, right? And then again, we have the privacy issues, right? And my video interview data will be used as training data for HireVue in future, even though I may never have give the company my consent. So those are the issues that we haven't been exploring extensively. So I want to summarize some of the things, if we call it robots, right? Robot screeners, what do they look for? really extremely closely tailored resumes, you know, in response to individual job ads, right? Going through the job ads and doing very close text analysis to generate your own version of job ontology related, for instance, to cybersecurity positions or data science positions, right? And then pay attention to the keywords, right? The repeatedly used words in the job ad and try to reflect those in our own resumes, highlight competencies, credentials, and experiences. So if we look at the resume, right? So for those of you who may be teaching resume writing or who may want to move on to the job market, here are some more like the hands-on tips. So traditional resumes, right? We have headings, okay, section headings, and then job titles, location, so on and so forth, and bullet list, right? And then the regular sections we have include education experiences, honors and awards, and skills. And then usually we'll have objective, right, to look for what type of position to do what. And for AI assisted screening, the objective is no longer as relevant, and we can help students instead to develop their summary statement. Remember, we are doing some kind of reverse engineering, right? The output of applicant tracking system, resume person, will be that summary statement. Why don't you generate a strong one, right? It's almost like the statement for LinkedIn profile, right? We all need to craft that section to make sure their search engines can pick us up, or their algorithms can pick us up as passive candidates, right? And then really, highlight accomplishments, measurable results, numbers, examples, right? Draw attention to unique achievements and accomplishments, and so on and so forth. So for instance, I have one passage, right, as a summary statement for content management. So it's a type of position for technical communication. So we can talk about the types of frequently, required skills from content manager positions, and then manage teams, and then there's some data, right? Okay, increase website traffic by how much? So you have some measurable results to catch the eyes of employers or recruiters or algorithms. Okay, so for those of you who have been doing research, right, I know for linguistics or AI, we've all probably write research abstracts or conference abstracts. So we'd like to emphasize that the new genre, the summary statement, it's almost like an abstract of your research paper. It's an abstract of you as a candidate. It's an abstract of your resume, and that's how you help to shape the first impression, right, that you may give to either AI screeners or once your name gets passed as a shortlist, right, shortlisted candidate, and that's something that may help to promote the candidate in that process. So to summarize, how do we make our resume, right, AI friendly, search friendly? So highlights specialized skills, keep in mind it will be used as text to data, make it clean, right, make it easy to scan, and then choose keywords strategically and customize our resumes in response to individual job ads. So those are the things we want to keep in mind. Okay, so I want to wrap up and say thank you. And if you have any questions, I'll be happy to respond.
Yes, ma'am. Thank you. Thank you so much for this interesting presentation, and also the topic that you have chosen. It is really very interesting, and I believe that most of us are really very, very in the dark, means how this process goes on, how one gets rejected, how one gets selected, and we often stay in the black. But today you have really shared with us some of your experiences, I believe, which will benefit all of us, and we will be more cautious, especially the facial expressions, the eye contact during the interview. They do matter, and we know we all become very nervous during our interviews. How much smart we are, something happens, runs in the back of the mind, and it happens to me.
and how these data, it was a very important point that you had pointed out, we might not get selected, but that data will be helping them to choose other people in future.
Yes.
So what a tragedy. And we have one question, like, should we make an attempt by, okay, just a minute. Should we make an attempt by putting suggestions to viewers of our respective universities to make artificial intelligence a part of course curriculum? I repeat, should we make an attempt by putting suggestions to the board of studies of our respective universities to make artificial intelligence a part of course curriculum?
I see that question. So,
Oh, fine, you can see it.
yeah. So, are you saying should we teach AI to all students? Is that the question?
No, yeah, the question probably I think she probably R.T. Singh Thakur wants to ask that in the curriculum should we be using preliminary knowledge, the basic, should it be taught to all, at least
I
in any standard?
Yes, yes, I think that's a great question. And thank you, Ultra, for asking that question. I really think, computational thinking, how machine learning, right, artificial intelligence work. That's almost like computer literacy now, right? Even though, for instance, like linguistic students, we may not every student will be doing AI or machine learning, but knowing how it works, knowing how it may impact our own profession, right? And knowing how our work may be used as training data sets, and that will inform and that will help to develop future AI tools, for instance, in education, in language acquisition, in writing, right? I don't think we can stop that. I don't think we can slow that down. But how do we provide high quality data that will still ensure the transparency and accountability and ethics of those technologies to be developed? I think that's something we all need to think, because for now, AI plus X, right? X can be anything. That's a trend. AI will be used in maybe most fields in the next decade. And we as professionals, right, in different fields, can help to shape that development process to make sure the end product will be more ethical, will be more accessible, right? Will be more explainable. I think that's going to be helpful.
Yeah,
But I
you
don't
have
see
also
everyone
pointed.
must be AI expert. No, that's not the point, right?
No, probably she was targeting especially the board of studies, the members who are sitting in the board of studies. Thank you, madam. Anyway, it has very nicely been answered, and I don't think we also have any more time. I personally had several questions, but I will never be able to get into that because we are truly facing serious technical glitches from the morning, and I really apologize to all, including to you, ma'am. Your schedule also had to be rescheduled. I'm really very sorry, but at the same time, I thank all of you, all the speakers as well as all the participants for bearing with the situation, and all the speakers for their enlightening, thought-provoking, and insightful talks. And hope tomorrow we will not be facing these kinds of problem. And Professor Willingding and other professors, those who are Indian, we will be getting a chance to have them in our college and in person. But Professor Willingding, online only I'm sending you the invitation from the on behalf of the organizing committee of our college, Haldia Institute of Technology, that we would be really pleased to have you in person in our college, because it was a very, very nice and a very current topic which we really need to know, but we generally ignore. We do not pay so much of attention. We just uh, sit frustrated we have not got the chance. But why we have not got the chance, how this screening is done, it's a really very insightful talk indeed. And thank you, madam. Thank you so much.
Thank
So
you.
much.
Thank you, Dante. Thank you, everyone.
Yeah. And now the feedback link will be posted. It is will be posted. It is for the participants. Please get the link and kindly send it by today.
I think uh, I think you all have got it.